Oh, can you explain what's going on here in your video?
So yeah, like inside of an enclosed structure, you're gonna get a coffee cup caustic. I call it the sun caustic. And because of Rayleigh scattering, it's gonna be in the far red spectrum. So you're not gonna see it physically with your eyes because it's in the far red. It's out of the visual spectrum. When the full moon and the sun caustic zone intersect at the ecliptic plane, we get a lunar eclipse. The shadow is not a shadow, it's a lensing effect. This is why we get a double shadow. This is why we get the ultraviolet edge. And this is why we get the red color. And this is why we get the 90-degree turn.
But how is it that everybody on Earth that can see the moon during the lunar eclipse all sees the same shadow from completely different angles on the flat Earth?
This guy works like a kaleidoscope, dude.
Well,
It's personal to you.
Not everybody sees a full eclipse either. There's a full eclipse path. There's an annular, a penumbra eclipse path, and then there's the far edge where you hardly see any effect at all.
Are we talking about a lunar eclipse or a solar eclipse?
That's for solar eclipses.
Are we talking about a lunar eclipse?
For lunar eclipses, everyone sees the same.
I want to hear if Joe Hanvey's talking about a lunar eclipse or a solar eclipse.
That's a good question.
About a lunar eclipse.
Okay,
so you're saying the people that are in daytime. You're saying the people in daytime see the lunar eclipse.
You're going to step all over me? No. What he claimed is obviously completely false. Everybody that can see the moon during a lunar eclipse sees the same eclipse.
That's not a debunk of anything.
So your friend Joe Hanvey here, who's this expert on modeling this, doesn't even know that. He's talking about some people see it full, some people see it partial.
Okay, we're not going to do poisoning the well,
no,
dude.
That's true. That's true about solar eclipses. The point about everyone seeing it doesn't change anything in our position. Do you understand that? Do you understand?
We acknowledge here that Joe Hanvey, your expert here, didn't know that during a lunar eclipse.
This is called poisoning the well, Jake.
God,
dude, what are you doing?
In here, he's got to come here and defend what was so blatantly wrong about your expert at modeling all this stuff, and he didn't know that during a lunar eclipse, everyone on Earth that can see the moon sees the same eclipse.
Oh my God, he didn't know something.
Well, he was just
hang him out to dry.
He just explained what happened to the solar eclipse instead of a lunar eclipse, and that doesn't change anything about the fact that you're avoiding the claim you just made. You can laugh all you want to, but you will not respond to me. Where what you claim somehow debunks flat Earth. There's Left Lane saying something that's absolutely worthless again. So you can't actually address what I'm saying to you, apparently, which is that you understand why that doesn't actually debunk our position. I don't think you do.
Why people on Earth all see the same eclipse from different locations on the flat Earth?
Yeah.
Yeah, because they have some magical bendy sky that works with some unknown physics so that everybody sees the same.
Oh, use a kaleidoscope. Let's go with a straw man.
Everybody sees the same face, and they all see the same eclipse from different locations and different angles all around the flat Earth for some unknown reason.
It's so funny that magical bendy sky is totally cool for 99% of your explanations of observations, though, huh? Magical bendy sky is totally acceptable when it comes to the Selenilian eclipse. That can be predicted months in advance. When it comes to long distance observations, when it comes to misplacement of stars, misplacement of planets, misplacements of the sun and the moon. That's okay. Magical bendy sky is
you're rambling now.
When it comes to Selenilian eclipses, I haven't seen many that show the disk of the moon and the disk of the sun at the same time. I've mostly only ever seen ones where it's like a lunar eclipse, but it's sort of light outside. But
it's the black swan. Is the excuse for the black swan that there is a magical bendy sky or not?
They're regularly observed where you see both the sun and the moon both above the horizon simultaneously. By the way, the thing from what Jake, what you were trying to try to make kind of a dramatic thing about Joe. Joe, weren't you just talking about different types of eclipses? Like there's annular, partials, total. I think that's what you were referring to, right? That there's different types of eclipses depending on the type of eclipse. Whereas Jake, I think, was talking about.
Well, I was saying the demonstration. Yeah, I was saying the demonstration was dealing with the lunar eclipse. I didn't mean to. I did say lunar eclipse people see, so I was wrong there. I admit that. Like, I'm not going to try to shirk that off. But yeah, the solar eclipse is where we see a direct path. But yeah, a full lunar eclipse, everybody's going to see that. But if it's going to be modeled, we have to account for not only the double shadow effect, we also have to account for the color change. And the globe does have an explanation for those things, but we can also model those things assuming a flat Earth inside of an enclosed structure.
Well, so here's the part
for
that
the
gets
double
really interesting,
shadow
right?
thing.
So what's up?
Oh, go ahead. I'll let you
Well,
go.
okay, so the thing is, you guys can't even explain a rainbow, and the rainbow literally requires like culmination of light. So you guys can't even replicate a rainbow in your model. Literally, you literally can't. And of course, we can. We're invoking containment. What's up?
What are you talking about?
Well, I'm about to
what you
explain it to you, but let's take it step at a time. Who's jumping in?
I think Seafoam wants to respond.
Necros, I wanted to say something about what you just said earlier concerning the magical bendy sky. So yeah, they can use the magical bendy sky to just explain the position of the moon and the sun. Still, if you have the moon and the sun being refracted up to be visible above the horizon, the shadow doesn't need to appear going from the top of the moon to down. Doesn't need to do that. It can do that. It's not refraction that is doing that. That's just the absence of the light.
Yeah. But just so the reason that I'm bringing up the rainbow, it isn't just a random thing, even though that's actually what started this conversation. And I was kind of trying to wait to say it, but whatever. But like it actually ties into this. So like you guys literally can't explain rainbows because you need like a collimator of light. You don't have that, right? You don't have a collimator. But you have to have one. You can't even replicate one indoors without
Don't need
one.
one.
No, yes, you
don't
do.
need one.
Yes, you do. Yes, you do.
No, you don't. No, you can
Well, that's
spray
funny.
some water
That's
and
funny.
a
When
light and a
Stanford
light source, and you can make a rainbow.
indoors.
Yes, indoors.
No, that's funny because whenever
you can.
Stanford and Harvard did it, they needed a collimator. So please show me your demonstration because Stanford and Harvard are retards, I guess, according to Left Lane. So go ahead.
I've seen a rainbow at
can do
work
it.
when sunlight showed through the window at the sink.
Sunlight is begging the question. This is the thing. Whenever these are actually experimented on by high-level university experiments, they have to use a collimator, right, indoors, or it can't be replicated. Now, here's the point of that: when you have a collimation of light, then then it literally effects of collimation of light is that the angular size doesn't change and that there's an apparent position. So it literally supports the fact that we would expect to see it the same everywhere on the Earth. And we can actually explain rainbows, which what do you know? What rainbows require give us no angular size change and give us an apparent position. And you
It's
guys
so
can't
simple.
even
It's so simple.
you can't even replicate and explain a rainbow.
That is silly for you to say that.
What's
Is
a
that all you guys
collimator?
got to say? Like, do you guys
That's
have,
not actually
do
a
you have
rebuttal, my guy.
rebuttal?
Yeah.
Like an actual rebuttal?
It's just
Yeah.
wrong.
Okay, is
A
he wrong
collimator-
about? Hold on, wait. Is he wrong about Stanford not needing a collimator? Are you saying that they didn't need one?
I don't know anything about Stanford. I could make a fucking
you don't know
rainbow in my
anything about it,
garage.
so shut
When
up.
I get home in the morning, I'll get up and I'll go out to the shop, close all the doors, and I'll make you a rainbow.
You can close all
Okay.
the windows.
Yeah, are you
We-
gonna
we
are you gonna use
just-
a light source? What light
we
source are you
just-
gonna use?
No, we'll just wait for this mythical observation that'll never happen.
What's a
What do you mean?
collimator do?
What do you mean by collimator? Yeah, thank you.
So
Because I know
think
mirror. I can use a mirror to
Wait.
replicate rainbow.
Seafoam, you trying to get in?
a collimator would be something that makes light rays parallel.
There you go.
Yeah.
Yep.
So like
Which is
in-
it does the same thing a mirror is gonna do.
Yeah.
yeah, you can use a parabolic mirror as a collimator if you put the light source at the focal point of a parabolic mirror.
Yeah,
Oh,
they
that's
just typically
crazy
use-
because
they use collimators, right? Like because it's more precise.
that's so wild because the Book of Job says that this guy's like a hard cast mirror. Huh? Crazy.
So like it's just a fact. Like when these universities study rainbows and they do the replications indoors, they have to use a collimator.
Yeah. Just
so Left just saying no, and I'm retarded. So I guess he's gonna shatter all of like known physics tomorrow in his garage. He says.
I wonder if you had layers of Atmos like that, you could possibly even make that, because I think in between layers of Atmos you get like a mirroring effect as well, which explains all of the horizon phenomena that you guys claim is because there's an invisible mountain in between you and something.
There is a Nobel Prize waiting for Left Lane tomorrow because he will be the first one. The first one.
Yeah, exactly. Because he's just completely.
No, it's on YouTube. Look it up. It's on YouTube.
We've all seen the one on YouTube.
This might be a little bit off topic, but a cool thing with collimated light is if I look through the back of one of my telescopes without any eyepieces, nothing changes size with perspective. Like everything that's the same size stays the same size no matter how big it is. It's a really strange effect.
With what? Yeah, like that's what I was saying. Like if you use a collimator, what's so interesting is that nothing changes angular size, and you're going to get an apparent position of what you're observing relative to the observer angle. This is like, is that a coincidence, guys? Is it a coincidence that if you actually use a collimator or a surface that replicates a collimation of light, right? Just like we know that is required for a rainbow indoors, so clearly it exists somewhere outside. Something is acting as a collimator outside. And what a coincidence. Your whole debunk of flat earth is that, the angular size doesn't change. And like we know that everything has to be in apparent position and angular size doesn't change. Well, that's exactly what we would expect to see with some type of surface acting as a collimator. So like ironically, like almost every single topic of this conversation, we have a viable explanation that can be replicated in real life and you guys don't.
It's over, dude. It's like super over. You guys asked for the model, you asked for a physical model, you asked for computer they're all there. They're every single one of them. You guys should just be like throwing in the towel. Or maybe you guys are flat earthers because you do hang out here a lot, so that does make sense.
And then think about this, when you see the rainbow, right? It looks like an arc. When you pop up, it looks like a circle. Yeah, because everything is changing relative to observer position. Everything we see in the sky is apparent because it's all interacting with the surface that acts as a collimator. So literally what we observe on Earth, if it's flat, is what is expected, and it's the only physically possible way to replicate what we observe. Now the ball's in your court. It's your turn to show us some type of physical demonstration showing us what you think is happening.
Can't wait to see Left Lane's rainbow from inside his garage.
Because I've been waiting for 10 years for that. Because when you use a glass of water, or when you use like some reflective surface or a mirror and a bowl, you're just proving our points, right?
Beast, I swear, for Left Lane, I don't know why he jumped into that trap. And he put himself in an awkward position.
He's in the Left Lane, man.
To say that we don't know how rainbows work and that we can't replicate a rainbow is absurd.
Okay, look at that, dude. Look at that.
Replicate
Look at that. Joe's got it replicated right now on screen for you.
Check this out. I've got these dice on the table. And with my regular camera, the far dice look smaller. But if I put my phone camera through the back of my telescope here and zoom in, you can see the far dice now are the exact same size as the close dice because the light is collimated coming into the telescope.
Yeah, dude, that's awesome, dude.
There you go. That's awesome. Yep.
And isn't that such a trip, dude? Like, so can you guys admit that?
It's the trippiest thing.
Dude, like on a flat Earth, if there was a surface acting like a collimator, then we would not expect the sun to change angular size.
Exactly. And then by the way, Seafoam, I appreciate you also demonstrating the hand of God video. So he
Oh, you
did that.
remember that?
Yeah, I remember that. So there was like a video going around where it's like, oh, it looks like the hand of God, but like Seafoam replicated it like exactly and showed that it was just an effect of what you had a
Yeah.
collimator on it, right?
No,
Yeah,
it's
I've
just
done that too.
because my telescope uses a parabolic mirror. It's called the Schlieren effect. It's one of those last name words that no one can spell.
Yeah, yeah.
To
But
me, that's just proof that the sun is really large and really far away, like they say.
What
it is.
does? What
To
does?
me, say the fact that rainbows are like that and that you need parallel light rays to make a rainbow is just proof that the sun is very large and very far away, just like our model says.
Oh my god.
Nope.
There was
Just like our model says, dude.
That's just
What
a
are you
thermal
talking about?
constant
Our
again.
model?
Yeah. Yeah, you know, humanity's model.
Do we have to actually rebut that, or can you try to rebut it yourself?
Ain't no rebuttal to it.
There's no rebuttal.
Ain't
You can
nothing
make
to
up.
it.
You can make up
Have you
some
been
shit, but
listening, dude? Have you even been
others,
listening? How
you
about
know,
the replication on screen Joe Hanvey just showed of Rainbow? Huh? Do you think
yeah.
that he
I
made
want
a huge sun and 93 million miles away to do that, bro?
no.
Is
The
that
fact that you
rainbow
need a
on the ceiling?
collimator, the fact that you need parallel light rays to make a rainbow, just shows that the sun is very large and very far away, just like the globe model says.
So
Maybe
you didn't see
Left and Cole
Seafoam's.
should debate then, because Cole says you need a collimator.
Well, what I mean, wait up. I just want to know. Can you think about a rebuttal?
Yeah, Steelman, your best rebuttal, Cole. The best one you know for that.
What do you mean, Stillman? That was my response.
But can you not think of a rebuttal? Like if you're that confident in it, you've obviously thought about like any possible explanation, right? To be so confident.
I just put up another demonstration.
No, I don't think in nonsense ways.
Okay, so in your model, the sun's light rays are not actually parallel.
Some of them are parallel.
No, none of them are.
The sun is much larger than the Earth, so that means that the light rays coming off from one side of the sun and the light rays coming off from the other side of the sun, some of them will be parallel with each other. Some of them are going outwards, some of them are going inwards, but some of them
What?
are coming in parallel.
Literally every single light ray that comes from the sun is not parallel.
Okay, that's just stupid.
Okay, no, it's actually stupid to not understand that's how light works on a sphere.
Trust
No,
me, if you
it's
think
not.
about it, if you process what he said, it's not stupid.
Yeah,
Yeah, like
because it's
literally.
like gravity, right? Some
Have a
of the
spherical object.
gravitational lines are parallel and some just.
You have a nearly spherical light source, which is what you claim the sun to be. That spherical object will just throw light rays that are, each light ray will be just divergent from the other next to it. No
Correct.
light ray will be parallel to each other. They will all form a giant sphere around that sun, a giant sphere of light made of millions and billions and quintillions and infinite amount of light rays, creating a sphere around that sun. All those light rays are just rays of that sphere of light. They are rays, and no ray is in a sphere is parallel to the other. They are all divergent from the center of sphere to the edge of a sphere.
True. I just wish more of
If
you
that was
guys
the
on the other
case, you wouldn't
side,
be able
like
to see the
Cole,
sun
Left
like you see
Lane,
it.
could you guys be more
That's
like
incorrect.
Seafoam?
That's incorrect. It's not a sphere coming out of it. That's so weird. Like you
No,
can
the
come at
sun
any
is not a
angle.
sphere.
Yeah.
The sun is not a sphere now, and it doesn't have diverging light
No,
rays that come up
Dude.
from
the light,
every
dude.
angle. So
Stop
therefore,
strong manning.
gravity upon the Earth
Stop
Wait,
is
did you
definitely
strong-manning.
guys
not
hear
pointing to the sun.
Biasticles talking before everyone jumped in? He was in the
That's
middle
all
of
right.
speaking.
No, we couldn't hear him.
Every
Okay, no, you
point of
did
the
hear him. You
sun.
just interrupted him, Wesley. Just try
I,
not to do
I
that.
You couldn't
just
hear him. We couldn't hear him. It's okay.
I just want the other side of the argument to be more represented like people like Seafoam, or if you guys can, be like Seafoam and actually have a rebuttal. That way we can continue the conversation.
Yeah, that is a rebuttal. Every point of the sun, has light going in all directions. That's why when you stand on Earth, you can see the main left side of the sun and the main right side of the sun. If you move over 10 feet, if you move over 10 miles, you can still see the main left side of the sun and the main right side of the sun and everything in between. That shows you that every point of the sun has light going in every direction. So that means some of that light will all be coming in parallel all the way across the span of the sun.
Oh my god.
Is that exclusive to
nice rebuttal.
I know that's over
how
your
can I
guys'
rebuttal
head
with you?
apparently.
First, how can I
but
rebut
that's
if
the
you're
way it
immediately
is.
cheerleading? How can I rebut if you're immediately cheerleading, pretending I'm not?
Oh, like your frog boys are?
That's not what happens. You guys, they literally just say an insult and go quiet. I was about to respond. It's insane. According to what you just said, then there would be tons of light rays that weren't parallel in the same sky.
Yes.
Okay, so then we have all kinds of light rays that aren't parallel on the Earth. There's never a portion of the Earth that has parallel light rays from the sun.
Yep, that's exactly right. That's why you can't see that. Why you can still see the grass behind a pylon. It's not completely dark because there's light rays coming in from different
Okay, so
directions.
you guys don't
So you
have
disagree.
parallel light rays.
Yes, we do.
Some of them
Most
aren't,
of them
Witsit,
are.
but
Most
some
of them are.
Now it's
What
now
don't
it's
you get
most of
about
them.
this? I said that while ago from the start.
Well, let me help hold your hand here, my guy. If light's going in all directions and then just some of them, so every single point of the sun has lights going in all directions. So if you take a couple rays out of each point, then occasionally you'll have a parallel light ray, then it would be a minority of the rays.
Okay, then how come we can see the edge of the sun?
No, chill out, buddy. Do you
No,
understand it
hold
would
on.
be a
Answer the
minority?
question.
No.
He
I'm
don't picture it,
rebutting
he said,
Cole.
he's just got
Do you
words.
understand
Yeah.
it would be the minority of the rays?
No.
And
No, you're not
there would be
understanding
there would be conflicting parallel rays. No, I understand it perfectly. I understand it
Okay,
perfectly.
how come we can see the edge of the sun? How
Why
come
would
we
we
can
not be
see the
able
edge of the
to?
sun?
Why would we not be able to?
Your
That's not
Necros, one of your white knighters came in and said comes from the center of the sun.
Dude, that's not a rebuttal to his
Do you,
point.
dude? First of all,
Yes,
the rays
it
all
is.
diverge out on a spherical light source, right? That's just a
No, they
fact. What you,
don't.
No, they don't.
Yes, light doesn't diverge from the source.
Let's get a
Not directly
citation for
outward.
these claims that you guys are making real
Okay, if
quick,
it
Wesley. Can
diverges
I get a
straight out.
citation? Can I get a citation for your claim, Wesley?
We're
Yeah,
only
I'm
getting a
gonna-
very small portion of those light rays.
That's the official claim, right? The official claim is that, yeah, of course, the light rays diverge out, but because the Earth is so much smaller than the sun, and the sun is so much further away, that the small portion of the sun's light that actually interacts with the Earth is pretty close to parallel.
You got it. Nailed it.
Yeah, man, you got it.
Yay! So now you guys realize that pretty close doesn't mean they are parallel, so you don't get a collimator.
You don't understand, man.
You always do the gay little giggling thing where you don't interact.
Witsit, how come we can see the edge of the sun?
No. Address what I just said.
See, he can't do it. He cannot do it.
You can't. You're
just
avoiding it.
projecting. Every time he gets really nervous and dunked on, he does this thing where he giggles
laugh
and then
weird.
claims
Yes,
I'm stupid.
yes. Reframe.
And then he obfuscates. And then what he does is
Necros, you're echoing.
Then after he
Go ahead.
obfuscates, he pretends that I'm running away from something. You can't obfuscate, and then if I don't just take the bait of the obfuscation, it means I'm running away. It's just like blatantly you gaslighting the room.
It's called whataboutism.
Somebody made a claim that whatever radiates from the center of the sun, and then you say they don't come in parallel. How come we can see the edges and the middle of the sun?
Are you going to engage with what I said first?
Yes.
Or you can't?
Yes, we're talking about parallel rays. How come we can see the edge of the sun?
light rays on the Earth in your own model are not parallel, thus eliminating the possibility
Most of them are.
invoking a collimator. None of them are.
Most of
even
them
the ones
are.
No, even the ones that people treat
What causes
as parallel
shadows?
Sorry, you don't comprehend this. I got you though. Even though in your model, even the ones that are close enough to parallel that we treat them as parallel for intents and purposes still are not parallel. They're like 0.5 degrees divergent in your own model.
Yep.
Okay,
Yeah,
how come we
0.5
get
degrees.
shadows?
That's right.
Okay, do you
It's
know how
not
a collimator
parallel,
works?
dude.
Do you know how a
How come-
collimator works? It has to literally be perpendicular. It has to be parallel.
How come we have shadows then? What's it?
No. Stop
Kind of
saying whataboutisms. Address what I
No.
just said.
This
question.
supports parallel rays. First,
He
real
said,
quick.
"No, I
clear
can't help but
question.
just argue with fallacies."
Okay, so he can't answer the questions. I get it.
Do you
Go
guys
ahead.
know how collimators work?
Are they better than half a degree? Are the ones used in
Of
colleges
course.
or
Of
rainbows? Are
course,
they
yes.
better than
Yeah.
half a
Yes.
degree? You have
Yes.
documentation of that?
Sure. Yeah.
Okay.
So
Let's see it.
okay, I got
Or
you.
I'll try to find it.
They have
But
to be literally perpendicular. That's how a collimator works.
Yeah, and you're talking about
How-
How,
Hey,
how much?
Seafoam.
What's the tolerance? What's the tolerance?
Seafoam, the
Oh, what's the
collimator in your
tolerance? There's
telescope, is it within half a degree?
Seafoam.
I don't think he's still in the VC Seafoam. He's in the text.
Yeah,
chat.
I should check first. I just assumed. I bet he has the numbers though.
He's not in VC.
Okay, are you guys going to the argument now that a 90-degree angle, nobody can ever get one because everything is actually like 89.99999 or 90.000? Is that what the argument's turning into at this point?
At this
No.
point, seems like it. It's close
Yeah.
enough.
Okay.
No.
Is that your
Right,
argument?
right.
Is that your argument?
His argument.
Your
was
argument is
that nothing is-
solipsism? That's what your argument
Wow,
is.
you're
anyone
asking
hearing
a
me say
question
no?
and talking over.
Hold on,
Yeah.
guys, hold on. Let's.
Yeah. Beasticle, stop chiming in with your white knighting. Go ahead, bull knight.
That's not my argument.
Wesley, can you
the
stop
claim was
just
made.
insulting people?
Wah!
Wesley, if you're just here to insult people and interrupt them, you're
No,
gonna
I
get
asked him many
moderated.
questions.
Stop doing that.
I asked two questions that he wouldn't answer. It's fine. Relax. Go ahead, bull
When
knight.
people
Sorry.
try to apply moderation, you just insult them and say they're white knighting. Please stop doing that.
I wasn't trying to.
Who's a mod?
I was actually gonna I was gonna moderate Torah and actually let you respond real quick, but you just.
Okay, then stop laughing when people bring up points. Then that's
Did
all
I
I would
laugh?
ask the
I didn't
moderators.
laugh.
Yeah.
It was
Yes, you did.
moderating Torah so you could make your point, and then you attack
Oh my gosh.
him
Whew.
for white knighting. You're just like this unhinged, vicious person sometimes. Just stop it.
being evil. Yeah, stop being evil. Thanks.
Dude, relax, bro.
Just
not
stop
that
what you're
serious.
doing. It's horrible etiquette. Just
I
stop.
will. Please. I will. Please stop. Thank
He
you.
said he will. Okay.
Thank you.
I believe you, Wesley. Now, can you address what Witsit was asking of you about the parallel light rays, and that if the sun is a sphere, right, and that's the light source, then if it's a spherical light source, then every single ray would be divergent from the ray next to it.
Oh,
Wait, can I
that's not true. That's not true.
Every
You can have
point has light going in all directions.
every point,
Every,
just like Cole
every
said.
point.
That's why I was saying. That's why I was saying. Well, no, Beast asked it. Witsit, if you say it's irrelevant, then why are you saying what Beast is asking it? So are you saying Beast's question is irrelevant?
Dude, just answer the question.
No, Witsit said it's irrelevant.
I want to
Is it
do
irrelevant
meta.
or not?
I want to do meta.
Yeah, he said irrelevant. Why did he say that? That's meta. I
Because
agree.
the reason he asked the question is because it's based on what the point you guys made.
Yeah.
Duh.
No,
and yes, your points are
the
relevant.
lies are the lines are mostly parallel.
Bull Knight's had the best argument so far. So you let me know when you guys want
Cool
to
meta analysis.
It's not meta. I'm trying to
Yeah, it is.
I'm trying to help you. Your argument sucks. I've already debunked it. Can we go to Bull Knight's
Okay,
argument? That's way better.
Then why can we see the edge of the sun and the
my God,
middle
okay,
and the
Bull
other
Knight,
edge?
Bull Knight.
What
I'm gonna
about
acknowledge what you said.
Cool.
They have no idea
That's
what
not.
we're saying.
Yeah, I know.
No, that's
I get it.
irrelevant. So
Sorry,
Bull Knight,
Cole.
the thing is
Thanks.
we have
Good try.
collimators that are as precise as 0.05 arc seconds to 0.1 arc seconds. That's like the error margin for the collimators used in the university tests. 0.05 arc seconds.
Oh wow. Really?
Do you know how they quantify that? I haven't looked it up.
Well, they call them like
basically.
you have like
Okay.
MRADs, right? But an MRAD is like it's like a lot larger, right? It would be like many decimal places for 0.05 arc seconds. So it's like
I mean, how do they? So they
whatever.
make one. They assemble one of these. Is there a way to? What is the means by which you test to see how collimated the light is, and can that be done for sunlight?
Oh, dude. Well, you realize that we have highly precise measurements of light, right? Like like in the early 1900s, we could measure light within a 1/100,000th of a wavelength.
Oh, bull
So
night
like,
knows.
But that doesn't show how columnated that light is. That's just a
do you know the
wavelength
collimator?
precision.
Yes, what we're trying to see, the collimator is making sure the light is parallel. Okay, it can make the light parallel within 0.05 arc seconds.
Yeah, I'm sure there's a device out there that can do that. I'm asking how do you measure the divergence of incoming light? And can that same measurement with which they use to determine the accuracy of the laboratory collimator, can that same technique be used to measure how collimated sunlight is?
Well, it's your model that claims it's 0.5 degrees, which is
No,
obviously
okay.
way.
If we
Okay,
can
what?
measure a collimated light from the lab instrument, then we could disprove that half degree value by taking that device outside and measuring how collimated the incoming sunlight is. That's my question. I don't know if it is or not. I'm just asking the room, really.
Well, the light outside, if there's if there's a physical surface that's acting as a mirror, right? We already know it's just a reflection back, which is where you can easily replicate rainbows. They want highly precise measurements in these tests because they're trying to understand rainbows. They use collimators, and of course, like a reflective surface is acting as a collimator anyway. But they want the highly precise measurements of it, so they use collimators that are extremely precise. And of course, like whenever you guys claim like the 0.5 degrees, you don't measure anything, right? The way that you do it is you take the beam, like the divergence, since you assume.
The width of the observed width of the source would be, that's where half a degree comes from, right?
You take the distance of the sun and then you take that in relation to the divergence of the beam. So it's a calculation. You guys
Right.
aren't measuring anything.
Is it not a calculation for the laboratory instrument? That's
It may, yeah, it's a measurement. The difference is we know the distance because it's in a lab. You can physically measure the distance, right? Like it's not like where we just make up what the distance is and make up what the light source is and make up what the divergence is. It's a lab. That's the whole point. Our site can physically replicate things in reality. In order to replicate what we see in reality, like a rainbow, you need a physical surface, something acting as a collimator. Your model doesn't have that though. Now, the point I brought this up for was if it with collimation of light, the apparent size doesn't change. Just like he just showed, if you have a line of dice on the table, the dice furthest away obviously looks smaller, but when he looks it through the telescope and it collimates the light, the dice furthest away looks the same size as all the other dice. So the apparent size doesn't change. It's going to be an apparent location relative to the viewing angle of the observer, and it's of course going to give you a rainbow. So we established that the collimation of light exists because it's a necessary antecedent of a rainbow. If that exists over a flat Earth, which we of course claim that there is a physical surface, or a lot of us do, then we're going to, for example, stuff like the sun isn't going to change apparent size, which is funny because that's what we see. And you guys claim that that's a debunk. It's not a debunk. Even more than that, right? It is also going to show apparent locations of everything in the sky, which what do you know? That's what we're telling you guys is that the sun's in an apparent position, the moon's in an apparent position, the stars are in an apparent position, everything's in an apparent position, including the 24-hour sun, including the star trails, et cetera, et cetera.
Do you
That
think
would be
you could determine how collimated a light is by comparing two different observations from different distances, even if you don't know the total distance to the light source?
Do you
So
accept
point A
that
and
you're
point
within a
B are in
medium?
line with the light source. Take
No,
a
you have to-
measurement at A, see how diverged it is at B, and then back propagate it.
how diverged it is in relation to what? You'd have to have a sensor at the actual collimator.
But if it's consistently expanding, you could do two measurements at any distance from the source and see how they change between those two distances. Potentially. This is all spitballing, like I said.
No, from my understanding, to understand what it is, you have to know the beam diameter and the distance. So.
Ooh, okay.
And you
So
can use
here's
two
the
positions. You can
question.
use two positions to do that, right? You would take like divergence 2 and divergence 1.
Yeah.
Right, over like the length 2 over length 1 or whatever. Yeah.
Yeah. That's what I was thinking. Now,
but still,
is there a relationship between the rate of divergence and so like when you make a rainbow in the lab, it's quote unquote apparently closer than a rainbow in the sky. Is that safe to say?
mm-hmm.
It doesn't look like it's miles away when you make one in a lab, does it?
Of course not.
Okay, so is there a relationship between the degree to which the light is collimated and the apparent angular size of the rainbow?
The angular size.
Like
That
angular
doesn't
rainbow's an
change
arc that
though.
has a diameter from your observation point.
The angular size isn't going to change. Like what the main thing you're going to tell the difference, like say that you have a collimator that does like 0.1 arc seconds and then or 0.05 arc seconds and then a collimator that does 0.1 arc seconds. The main difference you're going to see between those two rainbows is the crispness of the separation of light.
Okay, then can that relationship be mapped out and the crispness of rainbows in nature tell us the same thing about
Maybe
that light
that's a
source?
decent question. That's a decent question. I mean, I don't know if they did that. I don't know.
Yeah, I'll keep reading about it. Collimators are cool.
Yeah. But like I would say, right, we have to honestly concede this argument that's gone on for a decade that like on a flat earth, the apparent size of the sun would have to change drastically. If there was a surface acting as a collimator, it would not. So I'm glad now all the globers are going to retire the angular size change of the apparent size of the sun argument, right? We're now all going to be we're going to all now be intellectually honest and retire that argument now. If a flat earther invokes a reflective surface, then they don't need that.
One last thought about that then. So like that is only true if you're within the collimated beam, then that apparent size change won't happen. So when a sun goes horizon to horizon, the beam is at least that wide. Potentially wider, right? Is that a safe
Horizon to
assumption?
horizon to horizon for the individual observer.
If you can see the sun, you're within the collimated beam. It sounds like would be the conclusion.
Is my horizon the same as your horizon? I live in Florida. I don't know where you are.
Well, there will be a collinated beam everywhere.
Everywhere, right? That works in our conception. That's what it's trying to point out is that it's not a mutually exclusive thing to say, and it's not even an accurate thing to say that it would not work on a flat Earth.
And like the way I view this is like I find it highly improbable that we just coincidentally keep like that all of these necessary implications line up with the data. Like I'm supposed to believe it's a coincidence that if I do have a physical surface that's acting as a collimator, that will create a rainbow. But the effects of that. So the only way a flat Earth can invoke that, right, to explain the rainbow is to say, well, look, then we're not going to see apparent size change. And what do you know? So it's like
Any relationship
probably
between
coincidence.
collimation and polarization?
Is there a relationship?
Yeah, like when from a lab collimator, is that light also polarized or is it unpolarized?
Is it polarized?
And it might be different for there's different ways to collimate light, obviously. So
I don't know
it
that
may
it's
depend on that.
exclusive either
Yeah.
way, right? Like I don't know though.
Okay, I'd like to reframe the conversation back to what the original point was that collimated light in our conception works when you have something like a firmament or something of that nature. Witsit's point was saying that you guys and your explanation for rainbows is lacking. Anyone want to rebut that with an example to replicate a rainbow on the globe model?
Is the proposed cause of the rainbow that it's internally refracted light in spherical drops of water? Is that valid in the real world as compared to the lab, or you think there's possibly different ways that just talking about a rainbow seen at ground level with the sun behind you?
No, I think the issue is like the light, regardless if there's raindrops or whatever, right? The light that's coming in to interact with that rainbow has to be collimated. I mean, interact with the
or
rainbow.
or just parallel.
How come the sun has to
That's
be
what
less than 40
collimators
degrees
do.
above the horizon for a rainbow to happen?
Or it could be just parallel and doesn't have to be collinated.
That's what collimators do.
Maybe it doesn't need it.
Well,
Goodness.
we just discussed that though. You don't actually have literally parallel light rays.
Well, even the
Close
collimator
enough.
that's 0.1 arc seconds isn't literally parallel. Like that's just a matter of amounts, degrees of specificity. So
This is a very Jewy thing to do. What you
No, no,
guys
no,
are
no, no.
doing
It's just
now.
that's the most precise we can measure it, right? I mean,
sure.
the way that collimator works is it's using the perpendicular nature of it, so it's parallel, bro. Right? Like it's not the same
So
at
you think
all as it's not the same as all as like a distant divergent light source that eventually becomes closer to parallel. It is like literally using a reflective perpendicular relationship to give you parallel. So like, yeah, it's parallel, right? And
so you're
if you
saying that
Google it,
light is literally parallel, but we can't measure it to actually be
well,
parallel. We
what they're
get
gonna
within
say
0.1 arc seconds or whatever.
Well, yeah, because like 0.05, right? I mean, we only have such a so sensitive of measurements for all things, but we know the physical mechanism is reflection, which is perpendicular. So, like, what is perpendicular to horizontal? It's vertical, right? That vertical, if you had that another vertical line, they're going to be parallel to each other. But more than that, if you Google it and it tries to say there's technically no perfectly parallel rays, they're going to actually be talking about the transverse nature of light. Right. So it's like a technicality. Because like if you have multiple like say you have parallel light rays, but they're both transverse, well, like if they're not in phase, then they're not literally parallel, right? But now if you take a beam splitter, technically they would be. But like if something's like transversely moving beside another something else that's transversely moving independent of that, this is the reason that MMX had to use a beam splitter instead of just shooting two light rays at the same time, because they couldn't ensure that they were in phase, right? So like yeah, whatever. That's a technicality. It's inconsequential. It's definitely not the same as like a divergent light source. It's fundamentally different. This is why when we replicate it indoors, we don't just take a light flashlight and then go really far away, right? Like we need a reflective source. If what you guys are claiming is true, then just take a light source and go across the room and then show us a rainbow. But you're not going to be able to do that. You're going to have to use a reflective surface. Because again, we know reflective surface reflect the light back at an angle. Therefore, we're going to be able to ensure parallel rays. Right. That's why a mirror works as a collimator, because the light's going to hit the quote unquote hit the mirror, right, and then bang, come at a direct angle. So all those light rays are now going to be parallel.
That's dependent on the geometry of the mirror. But
Yeah.
a machine ground flat mirror at an angle will just reflect incoherent light if incoherent light's what's incoming, right?
Sure. This is why when you do it indoors, you normally need to use like a glass or like a mirror in a bowl or something. Someone say something?
I think I heard background noise.
So one thing's for sure, right? Even if we set the exclusivity of it aside for a second, like even if we yielded it, I don't yield it, but even if we did, and I can make your strongest argument, I'm just not going to do it right now. But even if we set that aside, and Bull Knight's like getting close to what I think the strongest rebuttal is. I just think it's insufficient, but we'll set it aside. Like, the thing is, what it definitely establishes is like a viable mechanism for what's observed in the sky on a flat Earth. And it shows like a consistency throughout, right? Like again, like okay, you need something that acts as a collimator. Physical surface does that. What do you know? Even ancient descriptions refer to it as like a cast mirror. It's like okay, well, if that's true, then what we would see is that everything in the sky would have an apparent position relative to the observer. And if that was true, then we would see that the stuff in the sky is not going to change apparent size.
Hold
And
on a second.
that's what we see.
Witsit, are you claiming that you cannot make a rainbow using a flashlight or
You
a
can't
spotlight?
make You can't make a rainbow indoors without something collimating the light.
Okay, well, here's a video of a guy that's making a rainbow in his garage using just an LED light bulb.
Go ahead, drop it. Because it's not true.
Oh, I was
I don't know.
muted.
I don't know.
Yeah,
I
where is
don't know if
it?
somebody
Oh, there
wants.
it
I
is.
don't know if somebody wants to broadcast that.
Yeah, I posted that earlier when we were talking about it. It's not a big deal.
The bulb has a reflector in it. So what's up with that? Why does
No,
the bulb have a
LED
reflector?
just projects the light. The LED just projects the light.
Is there a reflector in it?
What do you think the reflector does to it? What does the reflector matter in a bulb?
Do you know what do you know what the whole topic here is?
Yeah, a light bulb has some lights have reflectors behind it. What's your point?
Go use one without one.
It the reflector
Do you
helps
really
to
not
intensify.
know?
Yes. Do you know what the reflector does?
It reflects light.
Collimates the light.
It doesn't. It doesn't collimate.
It
It helps. It
diffuses
intensifies
light.
it. Yeah.
Do you not
helps.
know
It
what
intensifies
reflection does?
I just asked you if you did. It intensifies the light in one direction.
Does it reflect it?
Yes, it intensifies.
Nice.
What is the problem with reflecting the light?
That's the whole. How does a mirror collimate light?
I'm asking you a question. What does the reflector do that you have a problem with? when
Collimates the
comparing to
light.
sun? Okay, so it makes yes, correct. It doesn't radiate in all directions. It helps it radiate. It doesn't have to be in one specific direction, though.
Okay, do you
Okay,
understand
the
the challenge?
reflector collimates
Right? You know
the
that,
light.
right? There's reflectors on tons of
Can
lights.
you show
They don't
me a
all make a beam.
rainbow? Can you show me a rainbow made indoors without something collimating the light, please?
Well, what kind
if
of
we had a
reflector
strong
was
enough,
it?
yeah,
What kind of reflector was it?
yeah,
Because
I
I
don't know,
don't
it
think
looks
all reflectors don't collimate.
yeah. It's crazy.
What, this is like a long.
Do you agree? Do you agree that
cylinder
all
bit.
reflectors don't collimate?
It would depend on the way that the light interacts with it.
So you agree that not all?
Floodlights diffuse the light.
That wasn't his argument at all. All he asked for was a rainbow indoors without something collimating the light source.
So when we do that and show it, it's going to be something wrong with that light that it's going to disqualify it.
Again, listen very closely, man. They did this in university lab experiments. They had to collimate the light or they could not replicate a rainbow.
Can you show us that?
Yeah, we can do it in the garage.
Reflectors in directional light bulbs are specifically designed to collimate the light. That's what they do.
Yeah, we
This
can do
light
it in the
obviously is
garage.
not. Yeah, this light is obviously not going completely parallel in this video.
And the sun is not a center, single, little tiny point, emitting light in
Yes.
all emitting light in rays that are never parallel to each other. The sun is enormous, much bigger than the Earth, and
Oh my
every
gosh.
point. Quit interrupting me. Every point, all the way across the sun, emits light in all directions. Like I said before, that's why you can see the left side of the sun, the middle of the sun, and the right side of the sun. And then you can move over 100 feet, and you can still see the left side of the sun, the middle of the sun, and the right side of the sun. That shows you that every point emits light in all directions, because no matter where you're at, you can see all different parts of the sun, no matter where you walk to or
No,
anything else.
duh. That's how
Showing
light
like,
works.
so
conclusion,
some of
dude.
those rays coming in, since it is much bigger than the Earth especially, will be parallel. I don't care if they say near parallel or not. Some of them are parallel coming in. So when you
Dude, that's
have a
the
light bulb, like
worst.
in that garage, when you have a light bulb, even if they have something that makes those light rays parallel, that's still the same identical thing we see from the sun coming in. What's the problem?
Okay.
Arguing
That's
with
literally the
you guys.
worst argument I've ever heard. It's
No,
literally the
it's
worst
you
argument.
just you're
You're
full of
immediately
words, but
interrupting
no
me.
thoughts.
You're immediately
You
interrupting
interrupted
me.
him. Witsit, you interrupted him in the middle.
Okay, and then I fell back and let him. Now
saying you
you're
made a
interrupting. Shut the
terrible-
fuck up. Shut the fuck up. Why are
saying
you
that you made
talking
a
right now?
terrible
Why are you talking
argument,
right now? Why are you
saying
talking
you
right
made a
now?
terrible-
Make sure I don't get to rebut him. There
All
you
right, guys,
go.
just stop for 1 second. Guys, stop for 1 second. So yes, Austin did interrupt Cole, but immediately when Cole said, please stop interrupting, he stopped. Now, when Austin went to speak, Cole went on with several points, and then Finky is like, oh, but you interrupted him
I
once.
did not go on with
Finky,
several
stop
points.
trying to pseudo mod. You're not a moderator here. Please let the moderators here do the moderation. Thank you.
I did
So
not
what?
go
The
on with
only
several
reason I
points.
jumped
made
in is
one
I thought
point.
Cole. The only time I jumped in was when I thought Cole finished. I thought he finished his point 2 separate times. Okay. So and then Cole finished his point, and I got 2 words in, and you jumped back into talk after your whole long explanation. Anyway, dude, that's not a good argument. Your model claims the lights can be treated as effectively parallel because a small little segment of the light rays from the sun interact with the earth because it's so much bigger than the earth and so much further away. It's so far away. Okay. This idea, this like technicality you're grasping, I don't know where you heard this argument. It's terrible. This idea that light goes in all directions. Yes, we know that. So technically, if you have a bunch of different points everywhere all over the sun, that light's going out in all directions. If you grab a bunch of different little points, then some of those rays are going to line up parallel. That's totally irrelevant when you're talking about the light coming all the way through space and then interacting with the earth. What you would then have in what you're saying is a bunch of light rays intersecting in different directions. That's not what your model claims. Your model claims
Yes,
by
it
the
is what
time
my
that the
model
no,
claims.
it's not. Your model claims that by the time that the light gets here, right, that there's a small little portion of the divergent rays that interact with the earth and they're effectively parallel. So if what your explanation is, if your explanation is what's true, then you would never get a coherent rainbow from point A to point B. The light would be
Yeah.
scattering all over the place.
Light does scatter all over the place. Move left and right and keep seeing the sun. That's why when you look at the sun, it don't look like a itty bitty tiny point. It looks like a big circle.
So wait, we don't have parallel light rays on the earth.
Yes,
No,
we
they're
do
parallel
have parallel
within
light
half a
rays on
degree.
the earth.
But
Are
we have
you
tons of
not
light rays.
using?
Wait,
Are you not
No.
picturing in your head? Are you just using words but no thoughts?
no, listen
Honestly,
carefully.
is that how you
So
think?
so
Do you
so we
not
have
picture
like
in your
so
head what you're saying as
try
you
and keep
say
up.
them?
Try and keep up. Try and keep up. So you're saying the
Me try
vast
to keep
majority.
up.
Yeah,
Really?
try to keep up. Yeah, try to keep up. You're trying to say the vast majority of the light rays on the earth are not parallel?
Yes.
Oh, so the vast majority of sunlight on the earth is not parallel.
Yes.
And it goes in all kinds of directions and it has immense divergence.
All light goes in all directions.
So it has
From
immense
everything.
divergence. So the sun's light rays on earth has tons of divergence.
About a half a
Yeah.
degree.
No, it wouldn't be just half a degree. Not in his explanation. He's invoking the actual
No,
divergence.
Obviously, Witsit, they're not going to be 60 degrees crossing paths to each other.
Why not?
What do you
All
mean? Why not?
directions.
Because the sun
If light
is
goes
so
in all
far.
directions,
Because the sun is so far away. What are you
but
talking
wait, if light
about?
goes, but it doesn't matter. I thought it didn't matter how far away it was. If light
There
goes
they
in all
are.
directions, wait, time out. If light goes in all
There's an
directions from
image.
all, hey, buddy, I know you're going to post what I said. You're going to post the argument that I said. Cole's making a different argument.
No, it just shows parallel light rays.
No, yeah, that's what I said. So Cole's claiming that no, if you take a different point all over the sun, the light's going in all directions in every point. Therefore, if you take all the different directions from each different point, he just said that. That's what he
You
just
know good
said.
and well
Yes,
that
but
you're straw manning
the
it.
ones that are hitting the
What?
sun are not. I mean, the ones that are hitting the earth are not going at sharp, like 80-degree angles to each other.
Why not?
Obviously, because
Why
this
not?
earth is a lot smaller than the sun and it's a long ways away. But
Well,
some
why
of
would
those
that?
rays will be parallel, not near parallel, parallel.
So you don't even understand. So if you can't have your cake and eat it too. You just invoked that all over the sun there are little points of light everywhere. The light goes in all directions. So if you take all of the divergence of all directions of one point versus another, you could pull a couple of the rays out and they would be literally parallel.
Yes.
The reason I told you that's a ridiculously not good argument to try to be charitable here and change how I was going to frame that is that your actual model claims that by the time the light rays get to the earth, such a small section of the totality of light rays actually interact with the earth because it's so much bigger than earth and so much further away that we can treat them as parallel for intents and purposes. If you're claiming that the points of light that go in all directions interact with the earth that way, then you would have to claim that light rays are going in all directions, intersecting at all degrees. There would be no
No, that's
limitation
not
to
what
it.
I said.
Oh, no, you would have to say that.
No, it's an implication.
He's not claiming that they are parallel when he's talking about being able to see the both sides of the sun. He's claiming that they are converging into your eyes. They are converging to a point. They are not parallel, because if those corners from the sun are going parallel lines, they will just keep having the same size as the sun. They will not converge into your
It would
eyes.
be cool. It would be cool if we could just measure how collimated the sunlight is.
No. What's
think?
going to happen
Think
is
we could-
the point that left lane is making and the point that Cole is making is going to be recognized as contradictory, and you guys are going to show intellectual honesty.
Okay, but don't you think we could? Are there ways where we could measure how collimated the light is from the sun?
But can we talk about the topic on the table right now first?
Yeah.
We are.
Instead of
We're
you
talking
des-
about how. We're
no,
talking
you're
about how
desperately trying to.
collimated.
No,
We're talking about how collimated the light is.
you're trying to obfuscate away from the fact
You're
that
trying
Cole's
to run
argument.
away.
No.
You're trying to run away from the fact that
Look,
I'm
you're
right.
doing it. You're doing it
you know I'm
again.
right.
You're doing it again. Every single time this happens, when your side gets to where they can't get out of it, you jump in and obfuscate to another point. And then if I don't just take the bait and respond to it, you claim I'm the one running away. It is such a stupid tactic. Stop doing it. Cole, you made the point like five. You made the point like 5 or 6 times. Left lane, do you understand why Cole's
made
point
it
is
twice.
contradictory? Hey, you invoked this phenomena in response to the claim that the light rays aren't parallel on Earth. So left lane, do you want to argue with Cole?
Yeah, happy to agree with him.
Happy to agree with him?
A half of a degree, yes.
Half a degree, he said.
Oh, but wait, he's saying that they go in like all directions. So like if each point is going in all directions, there
I'm
would be a
not saying
light
they
ray.
go in all directions once they get to the Earth. They go in all directions in space, Witsit, from the sun.
What?
What?
Hold on, wait,
Wow,
wait,
it's
wait, wait.
amazing that a ball of light emits light rays in all directions.
hold
How
on.
mind blowing.
Yeah, exactly. Thanks. So when we made that point and you guys all denied it.
You're roboting a bit, Witsit.
You're breaking up.
Is he
Maybe it's
roboting
just
for
me.
anybody else?
Yes, he is.
Oh, he just okay. So, Witsit, try again.
And I don't even, and it's not, they can say half a degree if they want to. Some of those light rays will be exactly parallel coming in. They may not be parallel to a single point. If you have a single detector, you may not get parallel light rays. But if you set up two detectors 20 foot apart from each other, there will be light rays coming into those two detectors that came from 20 feet away from each other on the sun, that are hitting two detectors 20 feet away from each other on the Earth that are parallel to each other.
The necessary implication of that is that you would be able to detect light rays that intersect and are immensely divergent.
What tells you that that really works with it is the fact that you can see the sun as a large ball in the sky, and as you move, you can still see the whole sun.
You've said that 4 or 5 times.
So are you
I've said it 3
conceding?
times.
Are you conceding there are light rays on the Earth that come from the sun that have immense divergence?
Not immense.
It would be endless. It would be all the way through 360 degrees.
No, that's stupid.
Well, that's how all directions work.
So all directions means most of the light Witsit is going out into space, missing the Earth. Use your head. It's that lump
There you go.
up your ass.
Oh, you're getting there. You're
Witsit
getting
still
there.
man-
You're figuring it
Witsit
out.
still
You're
manned
figuring
up
it
pretty
out.
good. You still manned up pretty good.
So you're getting there and
But
you're figuring
now
it
answer
out.
my question.
Right.
Good. Now,
So
now answer my question.
wait up, stop. Cole, so now you're understanding.
still
You're
running.
understanding why you're conflating two different things. The light from the sun is not in your own model is not synonymous with the light, the small portion of the light from the sun interacts with the earth. These are different things.
No,
Do you
what
agree
I'm
with
saying
that,
is
Cole?
some of the light coming from the sun hitting the earth is parallel.
Then that means some of them would be divergent by 50, 60, 70, 80
No,
degrees.
no,
Why not?
because
Why not?
because the sun, the earth is so small and so far away, it's not wide enough to be that.
Wait, but
It's not
so it's
large
wide
enough
enough.
to be that. Its
What?
cross section is only its cross section is so small, or its size is so small compared to the sun that you couldn't get 60-degree cross paths of
I
light.
got.
You're contradicting yourself, dude. Okay,
No,
last thing.
you're
Let me.
you're just
Here, let's
too,
see if you can
have
figure this
no
out.
understanding of
Yeah,
things.
you're
You
just
talk,
projecting.
but you don't think.
You've just heard someone else say something like this. That's why you're so confident. You don't even realize that you're going against your own side. But let's just see if you can think about this. Okay, so there's a point on the sun and there's another point on the sun. The light's going in all directions, right? You're claiming that because the light's going in all directions in both points, that there's a ray from each point. If you pulled them out, that there would be literally parallel rays because it's all directions. So you would get rays of all directions from both points. So you could obviously just take a ray with the same angle from both points, and those would be literally parallel, correct?
Yes.
Okay, so that means what if there's a light ray that's at 60 degrees and then there's one at 80 degrees? Why could I not pull those two out?
Because the sun, the Earth is not large enough for that to be the case. It's too far away. It's too small. Do I need to draw this out on the whiteboard in here for you to
Here,
understand
let me,
honestly, do I have to draw it in
The
and
sun
tell
is
y'all?
only a half a degree.
yes,
The sun is only a half a degree.
That's
you can
irrelevant.
only get a half a degree of divergence.
That's irrelevant. Let me frame it like this for you. If I pull, you got two parallel rays, okay? Let's say those parallel rays are both at 70 degrees. You agree they'd still be parallel?
If you have two detectors and
What?
they're both picking up two, and the sun is, I guess you could say, if you're on the edge of the Earth and the sun is coming in at a steep angle to you, yes, you could say that both different light rays were 70 degrees coming in compared to the detector, the way
You
the
don't
detector was facing.
No, it doesn't matter about a detector at all. If we're talking about points of light on the sun and the lights are going in all direction, the rays are going in all directions, I can pull out any angle I want. So I can pull out a 70-degree angle from point A and a 70-degree angle from point B, and those would be parallel, correct?
No, it'd be missing the Earth.
Okay, so what angle hits the Earth?
It depends on what angle you want to use. If you want to say that straight on a 0-degree angle is what's hitting the Earth, and anything 0.5 degrees off of that 0-degree angle would be missing the Earth.
Okay, do you understand that a 0-degree angle from point A and a 0-degree angle from point B are going to be different?
If they're hitting the same detector.
They're going to be different.
Saying.
Oh, you don't understand it.
Here, I'll draw it up on whiteboard.
No, you just don't understand it, dude. If I have
I know these are mind-boggling thoughts.
Hold on, before we divide,
but they're really pretty
before we
simple.
do that, hey, wait, point of moderation, just real quick. Just want to reframe what's been said already. Cole, you said that the sun emits light rays in all directions, and yet when the light rays that hit Earth, when they come in contact with Earth, that's when you get the almost or closely to parallel light rays, right? I just want to make sure I'm steel manning what you said so far. Cole? Hello?
Let's see. All right. What'd you say that again?
I just want to make sure I steel manned you properly. You said that the light emits light rays in all directions, right? But some of the light rays will come in contact with Earth, and those light rays will be close to almost perfectly parallel, right?
Some of them will be parallel.
Some of them will be parallel. Okay. So Witsit's question
Yo, the
is
drunk guy
what?
is snoring. Someone mute him.
Who is it again? Hold
The,
on. I got it.
yeah.
Oh, yeah.
It's not me.
Okay, thank you. So Witsit's rebut to your point, right, was that then wouldn't that mean that there would be divergent rays, some even at 60 degrees, some at 80 degrees?
Not that steep. No, they can't be that steep.
No, they can be that steep. You'd have to claim they wouldn't interact with the Earth. So here's the part you're not getting. Here's the point you're not getting. Let's say point A is over here, and then say 700 miles away, we have point B. If we take the same angle locally of 0 degrees from point A and point B, and we put them up to each other, they will not be parallel. Do you understand?
Can you see the whiteboard?
Do you understand what I just said?
Yeah, can you see the whiteboard?
Oh, so I don't think you do understand it.
Can you see the whiteboard?
I can see the whiteboard, yeah.
Are you on the right one? It's blank right now, and I'm moving my mouse
yes.
back and forth.
So how many are there? Yeah.
There's several. Sometimes it pops up to different ones. Everybody else can see it too. I hope you can. All right. So if you have the sun, it's a big old giant circle. And I'm doing this with the mouse, so look over it. It ain't going to be perfect. So you got the sun. You got the
Can somebody
Earth
stream it
right
so
here. All right.
so others can see it?
Some of these light rays.
I don't see anything.
I just asked you, did you see me moving my mouse back and forth? I saw your
Yeah.
picture on here. Where'd you
Yeah,
go?
I see you moving your mouse. I don't see you drawing anything.
Yeah, can you stream it, Cole?
Oh, you have to zoom out a little bit. Probably might be zoomed in too far.
Okay, yeah, there you go.
Okay. So some of these light rays, some of them will be going from every point. Some of them will go this way. Some of them will go this way. Down here, some of them will go this
Yes.
way. Some of them will go this way.
Yes.
All right. Since the Earth is so small, even the ones coming from the main top of the sun and the main bottom of the sun is only going to be 0.5 degrees spread. Everything
Yeah.
else from these points are going to be out in space. But some of these light rays from here will go straight because some of them will go up, some will go down, some will go straight. Some will go straight from here. Some will go straight from here all the way down to the sun. As those light rays come in, some of them will come in, some of them will come in, some of them will come in, and they will be parallel because they leave over here at the same distance apart from each other, over here and over here. These light rays here that are parallel when they leave, since they're going in all directions, will hit over here parallel. Now, some light rays coming from way up here will hit at an angle coming down. Some will hit at an angle coming up. Some will hit at an angle in the center of the Earth and everything else. But some
Yeah.
that leave the Earth. But now to pick this up, that's why I said you have to have two different detectors. An individual detector is not going to pick up a point detector. It's not going to pick up a spread of parallel route rays. But two
everyone move their
detectors
mouse away from the
separated
sun.
a spot will pick up two parallel light rays coming in. But
Okay.
you cannot say that they will come in, they will hit the Earth at 80 degrees to each other like this and cross paths because the Earth is so far away that only the ones coming in from the top of the sun, the one coming in from the bottom of the sun will the ones that do hit the Earth will be 0.5 away from each other. So you
Okay.
can't have rays this steep coming across path
All
each
right.
other on the planet.
All right. Yeah. I know that was my whole point. Right. So like if you have what you're saying is at any point, right? So if you have a light ray going this way, this way, this way, this way, this way, this way, those are all coming from the same point. That's happening all over the earth, right? None of those are going to hit the sun or the earth except for the small little portion that comes right in the window, right? Right in the window. So if I take a little point and I go just at a slight angle, it's not going to actually make it. It can go like this. It's still going to miss, right? Now, here's the point I was just making to you, though. If I have a sun here, right? This point, point A, and say that's straight from its local point, and this is straight from its local point. Because this is a sphere, these 2 points are not actually parallel. Do you understand that? They're both technically straight from their local point, but because they're on a sphere, so this can be 0 degrees, 0 degrees. If you combine them, because there's a distance between the two, they're not going to actually be parallel. If you combine them together, it would look like this. Okay.
Where are you
So
drawing at? Hold on, I don't see where you're
right
drawing
above
at.
you, above you. I zoomed out and went above you, and it looks terrible.
Oh, okay.
If you weren't following me,
I
then it
got you.
looks super
I
bad.
got you. Yeah, I got
Okay,
you.
but it's
All
gonna
right,
look super bad. It looks
came
super
up here
bad
too.
now. I mean, if you're not following me while I said it, you're not gonna even know what that looks like. Like the point is, like if you have this right here, this circle, okay,
Right.
and so you got this point here, and this point here. From their local points, those are both 0 degrees. They're gonna come straight out. But if you actually take this point and compare it to this point, they're gonna look like this because it's on a sphere. 0 degrees at different points are not the same because it's on a sphere.
It does not matter if it's on a sphere. It's the direction compared to each other that they're traveling.
That's my point.
It makes no difference. If you got the sun right here, even if you have a light ray that leaves here and a light ray that leaves here, and this one is on, I don't know, positive 10 degrees, and this one's on negative 10 degrees, they may have left compared to the surface of the sun. They may have left at different angles, but compared to each other, which is what we're worried about, not the surface, we're worried about comparison to each other, they are parallel.
What I'm explaining to you, right, is if you have a sphere and you have a light ray at 0 and a light ray at 0, If you compare those two together, it'll look like this because it's on a sphere. There's a different angle for each position because there's a distance between the two on the surface of the sphere. Even more than that, though, this is how it is on your model. You have the Earth, then you have the sun, and you have all these light rays, but you have this little tiny Earth. And they claim that these are technically still diverging because it's coming out from different areas on the sphere. So they literally cannot be, in terms of geometry, they cannot be parallel because they're coming from different spots of the
Why,
surface of the sphere.
why can't they be
Oh,
parallel?
wait,
If
I
you
have a
have light
question.
rays going in all directions, even on a sphere, if you have light rays going in all directions from every point, even on a sphere, it does not matter the shape of the surface they leave from.
Oh my
All
God.
directions, it's all directions. So
Yeah,
some
so
of them will be going this way from this part of the sun, some from this part of the sun. These will be exactly parallel to each other. It does not matter. We're not concerned about the shape of the object that emitted them. We're concerned about the rays themselves. Throw the sun away. We're just talking about the rays. And those two rays will
meaning
be parallel.
meaning that
Can I say something real
meaning that
quick?
you can't say that. Meaning that if you take it, I consider what you just said. Meaning that you can't say that. Meaning that you are suggesting. I agree with that. If you suggesting that the light coming from the sun, from every point of on the surface of the sun, is just radiating like an explosion. It's just radiating in every point. It's just radiating like you are able to see the sides of the sun, and that light is able to enter your eyes. So it's diverging inside your eyes. So
I'm not
that light
talking
from
about
those
from a
points is
single, I'm not
radiating
talking
all
about from a single detector.
to
I'm talking
all
about two
possible
different
directions.
detectors. Two different detectors, just like two different people. If you set up a person here and a person here, and they're both looking at this big ass sun, this guy can see the whole sun, and this guy can see the whole sun. Both of them can see the entire sun from side to side. So
Don't you?
that means that he can look at this point of the sun, and he can look dead parallel, as straight parallel as he wants to, and he can see this part of the sun, showing, and they can do it at the same time,
That's
showing
our
that
point.
these lights are coming in, this light ray's coming in parallel, and this light ray's coming in parallel,
Showing that the
meaning
light
these light rays are exactly parallel.
showing that
Right.
the light in both sides of the sun is converging in the eyes of those both people in different position, in different sides of the earth. The light coming from both sides of the sun, they are converging into their eyes. Yeah, that's what I said.
No, you said
And
that
every
one
point light will
person, you
converge
said
into
one
a point, and
person,
every
you
point
said,
light will diverge into different
you stop
points.
talking, dude. Let me
And
Hold on,
respond.
guys. You guys. Yeah. Can
You
I?
said that specifically that one person looking at the sun can see the top of the sun and the bottom of the sun. No shit, but that's not what I'm talking about. I repeat, that's not what I'm talking about. What I'm saying is two people, they can stand a mile apart from each other if they want to, and they can set themselves up and they can look perfectly parallel to each other looking at the sun. They can line themselves up exactly looking at the
Okay.
sun, and they would, one could see light ray coming in exactly parallel, and the other one could see light in front of him
You,
looking at the sun exactly parallel. Those
cool.
two light rays will be exactly parallel to
All
each
right.
other. Not
Do you
near
notice?
parallel,
Okay.
exactly parallel.
Now, do you understand why that does not work for spherical geometry?
It
If
does
you're
not
on a
matter
ball,
about the
listen.
sphere.
Hold on. It does. That the implications of what you're saying. If I have a person, or let's say a detector in your terms, right? You have a detector 1 mile apart from each other. You have one detector, two detectors, right? You put the sun at the zenith of each person's detector, okay? Now, if you have parallel light rays from a distance between each other, and it's not just a distance between each other, it's anywhere on Earth, you're going to get that same effect. That is more towards our point of the Earth acting like a collimated lens collimating the light.
Yeah,
On a
it's
spherical
parallel.
Earth,
It's
you would have
collimated. It's parallel.
Okay, so if it's collimated, that leads more credence to our side because
No,
on a sphere, you would have divergent light rays based
no,
on the
you
geometry of a
wouldn't.
sphere.
Okay, the surface of the object in question, like the sun, does not matter because light can go in all directions again from every point. It's not like light is locked to go this way from this point and this way from this point. Light is not locked. The detectors are not locked to the Earth. If this is this blue line over here is the Earth, the detector is not locked to the Earth. It can be moved. It can be pointed any which direction you want. So two detectors can point in the same path to each other no matter what surface shape they're standing on, and any
Okay.
two light rays can leave no matter what surface shape they're
Yes.
on,
Can you look at the
parallel to
top
each
left?
other.
Can you look at the top left of the screen?
How is this hard to
Can
understand?
you look at the top left of the screen,
Yes,
please?
I see it.
Okay, you see the sun and you see the earth.
Yeah, I see it. I see
Okay.
the sun. Okay, the Earth is that blue circle below it.
Yeah.
Yeah, I see it. I see
Yeah.
it. I got you. I got you. Go ahead.
Okay, so these light rays right here, let's just change it to like green. Okay, these light rays right here, all these that are going to intersect with the earth, right? At this point right here at the surface, they look very close to parallel. Even in this drawing, right? These look very close to parallel. But because they're coming from a sphere, they're not. What the globe claims is this little, let me do this here. This little section here of intersection, they are barely diverging because such a small amount of the light is intersecting. What we were explaining to you though is even these two small little points here where I'm pointing the arrow, right? These two small points up here, if you take them really close to each other, it wouldn't even matter, and they're at the exact same degree, they're not parallel because there's a slight angle at which that light comes off the sun that's different than between point A and point B. That's all we're saying. So like
Yes, which
to get parallel rays, I already knew what you were saying before we came to the whiteboard. What you're saying is, yes, if you take them from the same angle at different points, they're different. But if you take different angles from different points, some of those will be parallel. The problem with that is to actually intersect with the earth over here, they're going to have to be relative, like pretty much the same. In your model, all of the rays that intersect with the earth over here are pretty much this coming off at the same angle, slightly different because they're different parts of the sphere. It's such a minor portion of the sun that this is actually not even close. This little section is way too big,
right.
right, in the drawing.
But like I said, I don't care about the surface they leave because every point they go in all directions. So there will be a point that they come off here. I'm over on the right side now. It's that big circle on the right, top right. You drew a big yellow circle over there. I'm over there. So that light ray will be coming off of there. Yes, it may be plus 10 degrees compared to the surface. But there will be light that's plus 12 degrees, light that's plus 14, light that's plus 16. Over here, there will be another light ray, or there'll be more light rays coming off. They will be going in all directions. There will be a ray coming off from this point and a ray coming off from this point that compared to each other, not compared to the surface,
Correct. I just
compared
said that.
to each
Now,
other,
okay, Cole, here's the
that will
problem.
be parallel.
Here's the problem, Cole. That's true. Also, what's true is there will be a light ray that goes like this and like
Yes.
this. And what are
Yes.
those going to do? What are those going to do? Those are going to converge towards each other. There's going to be another
Yes.
light ray that goes like this, right? Like this and like this. And these are
Yes.
going to divert. So what you're saying is in the earth over here, there are light rays that diverge, converge, intersect, and are parallel. That is the necessary
Yes.
implication of your point.
Yes. That's why when you have a guy standing on the surface, let me get back to the pen here. That's why when you have a guy standing on the surface right here, if you got one guy, he can see the left side of the sun and he can see the right side of the sun because these are light rays coming in that aren't parallel. They're converging together. But if he moves over 10 miles to this point, he can still see the both sides of the sun. And every infinite point in between. He can still see every point of the sun, showing that
So the
there
light is
are
radial.
parallel light rays coming in that are parallel to each other all the way across the sun, coming, or wide, as wide as the earth anyway, not all the way across the sun, but as wide as the earth. You will have some of those rays will be perfectly parallel coming in, not
Okay.
near, but
Yes.
perfect.
Okay, so we've just gone full circle to the point where I said this at the beginning. I acknowledge that, but I said the problem is that it's going to be a minor portion of the rays, like
Yes.
1% of them that's being charitable, which means the vast majority of the rays are going to be intersecting, converging, or diverging. So now when we
Yes.
talk about the context of the rainbow, you guys can't even invoke the
No.
parallel rays in the first place because you have a vast majority of the rays not being parallel in
No,
your own example.
I accept that you have to have on an indoor rainbow parallel light rays, but what I was saying, what started me saying every bit of this is you guys said that that light bulb that that guy used in that video had a reflector in it that made those light rays parallel. And what I said was that is those light rays coming out of that parallel is exactly the same as those light rays coming from the sun parallel. So to say that this invalidates anything is false because this is doing the same thing that the sun is doing.
In order to have an actual continual rainbow from beginning to end, you need the entire span of that rainbow to be parallel.
That was his point.
And you don't
You can't
need to
replicate
put
it without a reflector or a collimated like lens, essentially something that collimates the light. That's what his point was. So he's not trying to disprove the sun's collimated effect that you're claiming right now. Like that's not the point. The point is he's saying you cannot replicate it with any other light source without collimating that light source's light.
Yeah, I would
well,
agree to
more
that.
specifically, if they're going to invoke the small portions that are parallel as the culmination, then we would have like little tiny fractions of rainbows scattered randomly throughout the sky. We would never have a rainbow from point to point,
No,
right?
because it takes an exact part of the light hitting the raindrop to split it into what sees your eye. And since the earth is curved, that's why we see a curved rainbow.
You don't.
Oh.
Oh my goodness.
If you know, every light source will just use as the sun. Will just do as the sun is doing, and I don't disagree with you. Yeah, the light is radiating from every point on the surface of the sun. That's light will do the same exact thing on the lamp torch. So you don't need to collimate the light or use a reflector. If that lamp torch, the light source that use LEDs or anything, that light is going every direction because you can see the light of those sides of that lamp torch from every angle. You can go to the side of the lamp torch, you're going to go to the left, and you will be able to do exactly what you just suggested in that drawing with those two people in different positions. So yeah, that light is emitting from in every direction. And also, if you want to say it like that, because I don't take the light as individual rays. It's just like an explosion going in every direction, like a sphere radiating and getting bigger and bigger. So yeah, there is parallel light in that lamp torch. You don't need to collimate anything or use reflector.
Yeah, I wish he would have used a regular light bulb, like just a regular instead of the one
Also,
that
the
he
light.
used.
At least you're
Also,
honest
the
about
light
that,
will
Cole.
have some light that is some
So
light rays that are parallel to each other.
I would be curious to see what a regular light bulb done. Because you're telling the truth, if you have a regular light bulb, what the hell that was? If you have a regular light bulb, how do I get back to the
Hey, can you do me a favor? Hey, Joe, can you rewind that video? Cole, I want you to see what Joe's demonstrating right now.
There we go.
Are you able to rewind that video, Joe? If you can hear me.
But if you have a regular light bulb, like he said, you'd be able to see light from, you'd be able to see it when it's glowing on one side and on the other side, just like the sun. So you should
Hold on, I want you to look at
have
his
some
video,
of those
Cole.
rays coming in. All right, I'm gonna turn this screen thing.
Yeah, turn off
this screen
the
off.
whiteboard. Yeah, yeah. It's lagging up everybody anyway.
Where we
Sorry,
at
Joe.
now?
One more time, if you could rewind that, Joe. I just want you to see what Joe is putting forth here. The physical demonstration. And Joe, if you want to go ahead and explain to Cole and the rest of the audience, like what's going on here.
Yeah, it's just showing that a laser beam can mimic our sun. I mean, you get crepuscular rays, you get the bottoms of the clouds being lit up, the tops of the clouds being lit up.
How are you doing that?
You get
Isn't that cool,
doing here?
Cole?
Like, what are you doing here? How do
He's
you?
just shining a laser against the wall. It's just his wall.
But how are you getting clouds? Like, is it
It's a
reflecting from
physical
outside or
demonstration.
what?
I just used cotton
Cotton,
suspended with a trellis net. The sun is actually several feet behind the cotton and above the cotton, but as I move the camera, it follows the camera and it appears to be dropping, but it's not. Just the camera's moving. The laser beam creates the focal point, and dependent on observer angle, you see different light patterns. You can see the crepuscular rays there. I mean,
Isn't that amazing?
We can mimic our sun with something as simple as a laser.
Yeah, you're shining it against the wall, which means when it hits the wall, it's reflecting in all directions, and it looks
Yeah,
like
but it's not a
light
sphere.
source off in the distance.
It's a focal point. That is what the sun is. It's not. If it was, that's our point. It's like if it was a spherical light source, a gas ball, then you wouldn't be able to see the sun from anywhere on Earth with the same, like you have the same exact distribution of light. Like it just doesn't.
That's just false.
What?
You
So
literally
light bulbs
just
don't
said
work.
that.
Make it
No.
note that
No, I
the light
didn't.
bulb doesn't work. Light bulb doesn't
Light
work.
goes in all
apparently.
directions. Hold on, wait. You said light rays go in
Yeah,
all
yeah.
directions.
Light
From
bulb,
every point.
light bulbs don't work, do they? Because they're round. Therefore, they can't work. Got it. Where'd you go?
Now that laser is not a laser, even though it's a beam. When it's still got a width to it. When it hits the wall, it's got a width to it. That means that light rays on the left, they're going to be scattered in all directions. Light rays in the right's going to be scattered, just like we went over. And all you're doing is, instead of having a ball out there emitting it, you got something that's emitting it behind you and bouncing off a reflective surface.
So it wouldn't be exclusive
Basically
to like
imitating the same effect. But
right.
that does not mean that
That's
the sun
the
is not a
point.
physical object out in space. That just means you figured out a way to imitate the same effect. A really fucking cool effect. Don't get me wrong with the way he done it here. That looks
So it's not
really
mutually
freaking
exclusive.
awesome. But that does not mean that the sun is not what it is.
Yeah, where do we see that situation in reality?
Wait, time out. Do you guys understand that lasers culminate light?
The reflection's not culminated.
Yeah, the reflection's not not.
It's
when you back at your eye,
coherent. It's
culminated from a
coherent.
white wall.
Just concede it's not mutually exclusive, guys. Just be honest, man.
No, well,
We don't see anything like that in reality. We see the fucking sun. You want to talk about what the sun is? Look at the sun.
Oh, thank you, Left Lane.
But hey, do you guys agree that lasers are naturally collimated light?
naturally.
It's coherent.
Yeah, no,
coherent light.
They're synthetically made light sources. That's not what I mean by naturally.
That is a really cool optical illusion thing you got there, though. I like that. It's awesome. You can make a fucking video of damn good like illusion in a video with that right there.
The point is like the way that lasers fundamentally work, right? Like it's innately, even though that's not the right word either. So naturally is a better word. They automatically force the light rays to be parallel from the very beginning of the source. They like literally collimate light. And if you use a laser with a container, you can replicate like solar pillars as well.
Sun's not a
What's that?
laser, and we don't see a container.
Cool. Explain a solar pillar then.
A sun pillar?
Yeah.
I mean, like going through ice. Yeah, I've seen those. They're pretty cool.
Going through ice?
I
Yeah,
can
yeah.
show
Sun
you one
pillars
that I
usually
took from
caused by
work.
ice.
They're
Because
not going through ice.
If the phenomena we're talking about, the one where you see the pillar coming up from the sun when it sets, yeah, that's usually an ice phenomenon.
No, it's
Yeah,
not.
it's high altitude ice crystals.
No, it's not.
Yes. Okay, hold on a second.
It's seen it's seen all the way to the ground, and it's seen in deserts.
Hold on a minute. I'll post a picture of one that I took from work. Give me just
Sun
a
pillars
second.
are caused by sunlight reflecting off of tiny, flat, hexagonal-shaped ice crystals suspended in the atmosphere from high-altitude clouds like cirrus clouds, usually when the sun is low on the horizon at sunrise and sunset.
Yeah, of course. That's what you guys claim up magical crystals that we can't find. Just trust me, they're there for everything. That's not even
you
relevant.
can see ice crystals.
It's better than the dome.
Because you say so.
Well, what you say that they're not?
Yeah, I'm
Where's
about to
your
show a
data?
video of one. Right now.
I got a video up of sun pillars.
Yeah, they're
Only
awesome.
time
And
I've
they're
Sun dogs, sun
only time I've
columns,
ever
all
seen
that.
sun dogs and sun pillars is
Look
when
at
it's 8
that.
o'clock or cold.
They're perfectly replicated with a laser and a dome. Perfectly replicated. I've done it myself.
Except we can see the sun's not a laser.
No, you can't. How would you see that? Did you see his replication right then where he used a laser?
Look at the sun. Look at the sun. It's not a laser.
Did you see his replication right then where
Oh.
he used a laser and it looks just like the sun?
Good
cool,
rebuttal,
but
left
don't
lane.
mean the
The
sun is a
sun's not a
laser,
laser, though.
That's cool. It's not what we see in
Wait, the sun-
reality.
The sun is a laser.
He
now?
literally replicated exactly what we see in
Left lane's so funny.
reality.
Yeah, apparently
The
they
sun's
think
a
they got
laser?
a big laser set up somewhere shining on them.
You
Well, how
guys
come we
have
can
the
see the
worst
sun from
No,
rebuttal.
dude, you guys
Bro.
think that God needs to have like a physical like laser light, or do you think he could just create a collimated light source?
So
That
now
I
we're going to
don't
Out of
magic.
nothing?
Yo,
God did
yeah,
it.
so the source
Hey,
could be
out of
hidden.
nothing?
Now we're going to
You
go to
guys-
might not be.
magic.
We
Wow.
might not be.
God is
seeing-
magic. God
Dude,
is
one
magic.
second. You guys are all
Yes,
talking too much. One
yes,
second. The
Witsit. God would be
Shut up,
magic.
Cole. You stupid Dr. Phil bitch. The source might not be visible to us. The apparent sun might be something that is just apparent. That is just
Parents.
caused by the source.
I mean, where it
Literally,
appears to be,
there
right?
are poor kids in other countries that could have used the oxygen you just wasted.
Okay, so anyway, so the source
Okay,
doesn't
Dr.
need to
Phil.
be the source itself doesn't need to be collimated because the containment would do that. But the point is that for intents and purposes, it operates identical to a laser. So you guys sound retarded if you don't understand that lasers are collimated light sources, and so that if the light source went through containment, it would create a collimated light source, so it would be identical to the effects of a laser. Just saying the sun's not a laser literally means nothing. Do you know that lasers are collimated light? Yes. Are lasers collimated light? Yes or no?
That's like
Is the
saying
sun
everything
inside?
must be a television show because we can see people on TV.
Are lasers collimated? Yes or no?
Is the sun inside or outside the dome? I always get that
Anyone that
confused.
Are
answer the
lasers
question,
collimated?
I mean, the stuff you guys
Whole
come up
NASA
with.
shill left lane. Can one of you guys answer the question, please?
I posted 2
The
pictures. that I took of
coherent
some,
light. Lasers are
pillars.
coherent light.
Yes, that's an additional property that's not relevant to my question. They are collimators. Light from a laser is collimated. That's the entire reason of the coherency.
And
Yeah. Well,
and
the sun is not a laser.
No, the point is that the light from the sun acts like a laser.
He thought I was left lane. I win.
So the point is, dude, that it's the laser is a collimator effectively, right? Like the light from a laser is collimated.
the sun is not. The sun is emitting light in all directions.
Just
sun's not
dude, you're just being
The sun
goofy,
is
bro.
multiple frequencies. Hold on, wait a minute. Hold on. The sun is multiple frequencies. You can't have a collimated frequency of multiple frequencies at the same time.
Ooh,
You take a laser,
point.
put it through a prism. It comes back in one wavelength. You do that to the sun, you get the rainbow.
Can you make a rainbow with a laser, by the way?
No, you don't get a rainbow with a laser. You get like one frequency, maybe two, depending on your laser.
Bam.
That doesn't help you.
Yes,
The
it
light-
does. The light
listen,
from the sun is not a laser.
doesn't make a rainbow, huh?
You guys just don't understand it. So when I take a normal light source and I collimate it, can I make a rainbow? Yes or no?
No.
Okay, so you don't even know anything we've been talking about
Incorrect.
for an hour.
Hold on a second. A laser is a single frequency. It is collimated.
Hey, stop
That's
changing the
correct.
subject.
Wait a minute, hold on.
If
We're
I
saying
take,
that a laser. We're talking about laser. The sun's like a laser. A laser
yeah,
is a single frequency.
Oh,
It's not a multiple
hey,
frequency. You don't get a
if
sun. You won't get a rainbow from a laser.
I just said if I
You
take a
can't.
normal light source and I collimate it, can I create a rainbow? And you
How
said
do you
no,
collimate? How do you collimate a normal light source? Normal light sources aren't collimated.
we use collimators.
How?
What do you
Collimator.
mean
What's that?
how? What do you mean how?
Please tell me what a collimator looks like. That can do
What it
multiple
looks like,
frequencies. at the
buddy.
same
This
time.
is what they use in universities to replicate rainbows indoors. They use a collimator.
So what does one look like?
What does it look like?
The
Like
sun's
a
not a
tube?
collimator.
Your question is, what does it look like?
Yes.
Are you serious,
Yes.
brother?
Why
Brother,
don't you use your AI and get a picture? Be like,
Oh,
hey,
so
AI.
I need to do your research for you since you don't know what
No,
you're
we
talking
know
about.
what the
You
fuck
just
it
know.
looks like. You don't.
What does it look like? Tell me what
a
it looks like.
telescope's a collimator, bro.
Relevant. What the fuck?
I literally just said a tube. Don't you heard
Yeah,
that?
like it's a cylinder. It's a metallic cylinder. You don't But the point is, you were just pretending you knew it didn't work, and you just didn't admit it. Didn't even know what it was.
Bro, NASA
Why do you
showed us
do that?
degree
Collimator
of
doesn't
things.
do it.
He
Collimator
doesn't
doesn't
know
make
what he's talking
lasers though.
I
Yeah,
didn't
the
say. I
laser
didn't
has
say a
collimator, but
collimator makes a laser.
you can't take light and shine it through a collimator and say it acts like a laser now.
Yeah, okay, try to catch up. So I didn't say that a collimator makes a laser. Okay, what I said was a laser is collimated light, meaning that it's parallel. Okay, a collimator takes the light rays, makes it parallel. It's like a metallic cylinder. And the ones that they use in universities are insanely precise and can be measured down to like 0.01 arc seconds, which is like insane, or 0.05 arc seconds or whatever. So incredibly precise measurements. This is what they use to be able to, intricately and precisely measure the effects of rainbows and stuff and replicate them indoors. A laser is a collimated light source. So when you're trying to show different phenomena from the sun, using a laser is efficient because it's collimated light. Okay, so if you're just using like a typical dome that doesn't have a reflective surface, you're not going to be able to fully collimate the light. So if you want to replicate the actual effects of the sun, you guys thought it was a slam dunk that lasers aren't, you can't just easily make a rainbow with the laser because of the frequency, and it wasn't a slam dunk at all. Can you concede that you were wrong?
What? That you can't make a laser by collimating light? Or
That's literally no. Do you agree we can make rainbows by collimating light?
We make rainbows by collimating light.
He doesn't know.
Yeah, that's literally how we make them. That's the only way to make them. You actually can't make them without one.
No, the sun is the rainbow is the opposite of a collimator. You're taking light and you're splitting it into different.
Okay, that sounds like a you problem because
It sounds like you don't understand how rainbows work.
It has collimated light. I know that.
No, wait, hold on, stop. It's the opposite of a collimator. The rainbow
Oh my God. Is no one going to save this guy? Is no one from his side going to save him?
You think that a rainbow is collimated?
Yes.
No, the rainbow is spread out.
Dude, the light
is the opposite of collimated.
Brother, the light that
Talking about the light
creates
coming
the
in,
rainbow.
NASA.
Yes.
The light that's coming in to create the rainbow is what he's talking about.
Yeah,
it's
collimated.
Not once
coming
it
in parallel
turns to
from
a
the sun.
rainbow.
That's correct. You want to call it collimated? Okay.
Light doesn't come in parallel from the sun in your model.
It does. Yeah, it does.
No, it doesn't.
Yeah, within 0.5 degrees.
Oh.
You guys keep saying that some of the light rays are exactly parallel. They're not.
But that would not be a sufficient
parallel
mechanism for the rainbow because that would have little portions of the rainbow scattered all throughout the sky, right? It would. In fact, you would never even really get a rainbow at all.
Shadows are fuzzy. It's also why shadows are fuzzy a little bit. Shadows aren't. If you look at the edges of a shadow, they're kind of fuzzy. Yeah, that's why.
That's a cool story.
Dog over here, dude.
Yeah, no, what do you mean it's a cool story?
Well, exactly what I said.
Works.
So you admit though that you were just randomly saying that that you were unfamiliar and ignorant about it. It's fine. It's not a big deal. But like whenever universities try to replicate rainbows, they use collimators, right? And they're highly precise collimators. And then the effect of a collimator is that you won't see apparent size change.
So you don't need collimated light to make rainbows. You can use a standard desk lamp or flashlight, which works fine.
What?
And also we know that the sunlight is off by 0.5 degrees, so it's not perfectly collimated light either. So
I see what
you
You're just reifying your model and begging the question.
No, it's observable. It's
No,
observable.
I'm telling
This
you
dude
that
just
I'm telling you
begged the
why.
question.
No,
You can look
Austin.
at the sun and see it has a physical size of 0.5 degrees. The light coming from it is not perfectly collimated, not perfectly parallel, but it's pretty fucking close.
But there are light rays coming from the sun that are perfectly parallel. Not all
Wait, can
of
you
them,
guys show me a
only a
measure, a
small
physical?
percent, but there are perfectly parallel rays
How
coming
do you
from the
guys
sun.
measure how do you guys measure how collimated the light is on Earth?
That's a
The
non
answer is you
sequitur.
can't. The answer is you
That's a,
can't because the equation to determine the collimation of light requires knowing the divergence of the beam and then the source, the length to the source, meaning the distance. You assume it and then reverse engineer your claim.
Wait a minute, hold
That's a
on.
cool story.
You don't assume that the sun is 0.5 degrees. You fucking measure it.
That's not a distance.
Don't need a distance. You need
You
a
literally
angle.
do need a distance to
You
determine the
literally don't
collimation
need it.
of light.
You
Okay, what's the
literally don't
equation?
need it.
What's the equation then?
You know since when do you know equations? I don't talk math to flirts.
Okay,
You
it's
don't know
D2
math for
minus
shit.
D1 over L2
Dang.
over L1. So you don't even know what you're talking about. You didn't even know what a collimator was 5 minutes ago. Just chill out. The point is that we're pointing out, we're not even making a mutually exclusive claim. I mean, you kind of can because you guys actually don't have parallel rays. But even outside of the mutually exclusive claim, even outside of that, what you guys need to do is concede that yes, you're right. On a flat Earth with a physical surface collimating the light, you would be able to explain how you have a rainbow, and you would be able to explain and expect that the angular size would not change.
so we can make rainbows
So wait,
with
hold on.
best
So the
glance.
angular size doesn't change now because the sun is collimated, even though it's like 2,000 miles up when it's at noon and 6,000 miles away when it's at setting. That won't change the size.
No, we don't believe it or not, we don't invoke your made up version of flat Earth. So we only see the
Wait a
apparent
minute.
sun.
What do
We're
you mean
not
made up version?
your made up version
Apparent
where you
sun. You
just
mean
claim
Who
where it
gave you
appears
those
to be?
distances?
You mean
What the fuck?
the made up version? You mean apparent as in where it appears to be? So how
that's
high is
what
the sun?
apparent
So
means.
are you saying the sun
How would
lives
we
as
know
further
how
away?
high the sun is if we only ever see the apparent sun?
What do you mean the apparent sun, where it appears to be?
Yeah, how high is the sun in Joe Hanvey's model?
You could if the Earth was flat, you would be able to triangulate the height. You know
How
how
high is the sun in Joe's model?
I have no idea. He hasn't told us.
Well, he just showed us a replication of the sun through the clouds using a laser. So the light source that we see, how far away is it?
Nice. How far? I don't know. You tell me. He doesn't know.
We wouldn't know because we're seeing the apparent light source.
Apparent, you mean where it appears to be?
That's what it means, yeah.
Yeah. That doesn't mean made up or fake. It means where it appears to be.
Okay, so why are you asking us about a physical distance then?
Well, you should. If it doesn't have a physical distance.
No, it's not that it's not that it necessarily doesn't have one. It's that it's unknowable because we perceive the apparent. Yeah.
I see. So where would the apparent sun appear to be then? You could triangulate where the apparent.
It's an
sun
apparent
is, right?
position. It changes relative to
Hold on. If
observer.
I knew where it is and I know how far away it is, and I could get two people at two different locations looking,
Nope.
or is it a different sun for everybody?
Yeah, it's a difference. That's what apparent means.
The personal dome.
It's
So
literally
everybody's
like
in
a
their own
rainbow,
personal
dude.
dome. Got it.
Wait, NASA, did you know that a collimator makes things not change apparent size?
Collimator doesn't change apparent size. This is your new shit.
No. We just had a Glober in here do the demonstration.
Yeah, seafoam.
So he took like 4 dice, laid them on the table. When you look at it, you see that the dice furthest away is smaller, has a smaller angular size. But when he looks to a collimator, his telescope, he sees that the dice the furthest away appears to be the same size as all the rest of them because you don't
How
the
far
angular
away?
size, it doesn't matter. It
doesn't
goes
matter.
from it goes from a change in angular size. This is a known effect of collimation. So the thing that you just didn't know what was 5 minutes ago. Let's not pretend that you understand it right now. That's stupid.
So the
You just
collimate,
found out yourself with that.
let's pretend
Well,
like
I
you
just
would.
found out when.
So is the sun
Are you talking
perfectly
about I just
collimated?
found out when?
Is the sun
No.
perfectly
I
collimated?
knew this
Is the
a
sun
When
while
perfectly
back.
showed
collimated?
you.
Dude, me and
No,
Piezo
he
were
said
talking.
no.
Me
He
and
told you
Piezo were
this.
talking about this 2 days ago.
Is
No,
the
he
sun
told you this,
perfectly
and you said, "Oh,
collimated?
really? Show me."
I didn't say, "Oh, really? Show me you're a liar." My whole first point was that apparent size doesn't change, and then he said, "Yeah, that's pretty crazy," and he showed it. And he like,
He
dude, my whole
agreed.
dude, exactly. He showed it to support it because you guys were denying it. So someone from your own side had to show you. And
How
so
far
the
away
point is,
was he looking in his telescope?
it doesn't matter.
Oh my
yes, it does matter
gosh.
because you think the sun's
You
perfectly
don't even know what we're
collimated.
talking about, dude.
Are
You
you
weren't
claiming that
here.
I'm
there's a certain?
showing.
Are you
Man,
claiming there's a certain distance away that all of a sudden the collimator won't keep the same angular size?
Well, you know, the
I'm
further away it is, the more it spreads out, unless it's perfectly collimated.
I'm showing minimal. I'm showing minimal angular size change right now.
Yeah,
And how
and that
far away are
actually
you?
that shows that if we can explain if there's no angular size change or minor angular size change, both work on our model. It would be relative to distance.
And you guys also have the
So
problem
you're
during
throwing away
during the diff.
you're
Shut
throwing
up!
away
Shut up!
perspective
Shut
now.
up! Shut
You're
up!
throwing away perspective now,
Shut
right?
the fuck up, dude. What the hell's wrong with you guys,
Oh,
dude?
wait, hey.
During different times here in your model, the sun is like a million miles farther, and there's no angular size change. You guys have the same
There is an
problem.
angular size change.
Well,
But
this is what's so interesting, right? According to the globe, the size of the angular size of the sun does change, and it changes
over
point
6 months it
point
changes.
oh no, it changes every day. Changes
It varies.
point.
How much?
Okay, so wait, does it
How much?
change
How
or
much does
not?
it change
Though?
every day? How much does it change every day?
0.08 arc seconds.
And you
So
think
it
you can
changes.
see 0.08 arc seconds?
Did I say you could see it, or did you just make that up?
Can you see 0.08 arc seconds?
Did I say you could see it?
Then if it doesn't change, unless you
Do we
measure
have
the
instruments
0.0
sensitive enough to measure that?
Yeah, probably. But if you looked at
Okay,
it,
so
you would say it's the same size.
can you provide empirical measurements verifying the geometric necessity of a 0.08 arc second change up to noon and then back down 0.08 arc seconds to sunset?
So can you provide on the flat Earth to check that would
Deflecting.
change much
Why are you
more than
deflecting?
that?
Why it
So it
doesn't
would
change much more
much
than that.
more?
We just showed it
It
wouldn't
would.
change if it's
Oh, it would.
collimated
According to
light.
perspective, it would change much more than that.
No, collimated light wouldn't change.
Oh, it wouldn't because it's perfectly collimated, right?
Even if it's not perfectly, it could be the same excuse you're making right now, which is that the change is so small that it's not detectable. But it
Oh, I
actually,
see. So you're ad hocing an explanation now.
time
Got
out,
it.
and it also could be perfectly collimated. Like we can.
Ad hocing an explanation.
I get that you're going to spiral about this, but
So
If we don't have a concrete
is,
model, it's no ad hoc, dude. What?
is the sun inside or outside the dome? Is the sun inside or
Hey,
outside
I
the
wasn't done. So on
Is the
Earth,
sun
hey,
inside or
bro, I
outside the
wasn't
dome?
done. I wasn't done.
Dude,
Sun
don't get
inside
muted.
or outside the
We have
dome?
enough Globers.
NASA
Can we just
Shill,
mute
if you
NASA
can't
Shield, dude? We don't
control
need
yourself, you're going to be muted,
Inside or
man.
outside the dome? Simple
NASA
question.
Shill, do you hear me, bro? If you can't control yourself, you're going to be muted until other people finish.
Yeah, I was
is
about
sun
to
inside or
say, dude,
outside the
just
dome?
fight the urge to be muted. Just calm down. Let Witsit speak. Go one at a time. Go ahead, Witsit.
So
Ask a
check it
simple
on. So
question. How come nobody wants a simple question?
when we replicate the rainbow. When we replicate the rainbow on the Earth, right, like in a lab, and when they use a collimator, we can attain precision down to 0.05 arc seconds on Earth. Mankind can do that. Do you think that God could attain perfect collimation of a light source? Of course he could. And even if it wasn't perfect, it wouldn't necessarily be detectable. The irony is, though, the distinction, the exclusivity, is not just that you guys claim a really small amount of angular size change. You guys claim that it changes up to noon, then changes back down to sunset. Can you guys show me any empirical measurements of that? Because we have devices sensitive enough to detect the amount you claim it changes. Or are we just supposed to believe you?
Is the sun inside or outside the dome?
Okay, so you guys have no evidence for what you believe. You just blindly believe it. And it's just
You ain't got no
funny.
evidence for God. You just
Yes, I
blindly
do.
believe
Yes,
it.
I do.
No, you don't. No, you
Yes,
don't.
I do.
I want
Yes, I
to ask a
do.
simple fucking question, Witsit. Is the sun
Why would you
inside or outside the
Cole,
dome?
why would you try to bring up the thing you know I'm gonna dunk on you with?
You're not, because you
Inside
have no
or
evidence for
outside the dome?
God.
Come on, Witsit. It's one or the
I
other.
don't want to give you the life jacket because it's too much light work, to be honest.
Well,
Inside or outside the dome, Witsit?
No,
Simple
you
question.
don't, Witsit.
It could be both. It could be both.
Oh,
There could it could be a layer. It could be layered. It
Oh,
could be layered. It could be layer containment. So it could be outside
layered
the lower.
containment.
Yeah. So it could be outside the lower levels and then inside the totality of it.
With or
Which is actually
without
what
a
I think it is.
kaleidoscope. With or without a kaleidoscope.
So there are multiple domes?
Well, that's what's so interesting is you don't need the kaleidoscope.
The kaleidoscope is the collimator.
Yeah. Well, I mean, look at
Wow,
you
that's-
coming on over to Flat Earth.
Witsit, will you agree then that we don't need a collimator to make a rainbow?
We don't want P-Finky.
Why would I concede that? But what's inside of a kaleidoscope?
We can make rainbows with just desk lamps or a flashlight without collimator.
You can use light sources without reflectors.
Yeah, correct.
Can you cite it? Can you cite a demonstration?
You guys said this already.
No, yeah, but he doesn't think that we can make it without collimator.
Reflectors collimate the light.
No, they don't.
Yes, they do.
No, reflector. Not
What do you
all
mean by
reflectors
reflector?
collimate. Yeah,
Like
Reflectors
reflectors
in
can
light,
make.
that's literally why they're in light sources, like a flashlight. The reason the reflectors are in there are literally to collimate the light. You didn't know that?
Okay, what is your
Well, like
what
you
is your
say my mirror, if
definition?
I shine a flashlight into a mirror,
Yeah.
that light's now collimated?
Well, the middle of the beam part is, you know, how when you have a flashlight and there's like maybe a 2
Well, I
or
get-
3 inch
What if I have
diameter.
a fire with it? What about
No,
a fire?
I guess
I
I
have a
guess
light
the
bulb. I put a light bulb up in front of a mirror. Is that light collimated now?
Part of it is,
Right.
yeah, and the point is that you only need
part
a
of it
section of it.
is.
You only need a section of it to create rainbow.
Wait,
What about an arc
what do you
lamp?
wait? What is a well, wait? Hold on a second. I just want to understand from Witsit what he thinks collimated light is. Like, what is collimated light? Is it perfectly parallel, or is it down to 0.5 degrees, like you said before, or can it be anywhere between 0 and 180 degrees reflected?
Anywhere between it?
Yeah.
What? No.
So a mirror is just 180 degrees reflection. Like a perfect laser would be close to 0 degrees, right? Or perfect, yeah, perfectly straight back at you in a beam. So what do you consider a collimator?
Well, that's what's interesting. Technically, collimated light is parallel. Like that's what it actually is. Yeah,
Yep.
but like we don't attain perfect collimation.
I know, that's why
really,
I'm asking you. Like, does it have to be very close to perfectly parallel? Because reflectors are not close to perfectly parallel, like Finky said, with a mirror. So we can make it with like a desk lamp that has very little collimation.
Do you know why that doesn't help you?
No, I'm asking you. We couldn't make rainbows without collimated light.
That was his point. Oh.
I know I know,
When you
but
have a
we can.
reflective,
But we
when you have-
can.
When you have a reflective surface, though, the light is going to hit that, and then there's going to be some of that light that's going to be all coming off of that mirror, in the case of a mirror, in a parallel fashion, which allows for the collimation.
I agree with you that some of it is, but a light from any light source is coming off partially parallel. Like your light bulb, you have parallel light coming off from your light bulb too. So I'm just wondering what if he says
You can't make a rainbow with a standard like
Yes, you can.
standalone rainbow. I mean,
A
a
desk
mirror.
lamp.
You couldn't make it. This is what
No,
I'd venture to
I'm
say.
not
I
talking
don't
about.
know
You
this for
can't make a
sure.
rainbow
No,
with a
I
standard.
was talking.
No,
I was
you
talking.
weren't.
He didn't
Yes, I
finish his
was.
sentence, Pinky.
And my point's really quick. I'm not 100% sure, but I'm pretty sure you could not make a rainbow with a light bulb and a flat mirror.
I know exactly. That's what I was about to say. You can't make it with like a standard flat mirror.
Yeah, because
but you can make it with a right, and you can also, but you can make it with a desk lamp.
But you
Do you
need to have a mirror.
Do you
need to have a
understand that
mirror as well.
reflectors in flashlights and stuff, they actually use specific reflectors with like a very specific curve that creates a parabolic shape?
Yes, I understand that.
Bro, are you guys even arguing
Why?
what
Why do
versus
they?
flat? How
Hold
is
on a
this
second. Hold on. Let me
either model,
answer. Let me just go back and forth with him. Is that do you consider that a flashlight collimated light?
It's specific lights are built differently, right? But whenever a light source has a reflector in it, doesn't just have a flat mirror. It's not like that's not what reflector means.
Understood.
Can you stop interrupting me? In fact, the very reason for the reflector is to collimate the light. It's built at a specific curve to create a parabolic shape that then creates a focal point, collimating light.
Okay, so you are saying that a flashlight is collimated light then, even though it's not close to parallel. It's closer, but it's not close to parallel like collimators are.
Point, dude.
It depends on what light source it is.
If he's calling,
according to you guys, you should be able to create a rainbow with a light source without a reflector.
Yeah, I think you can. If you use an arc lamp or something.
Okay, so you guys agree you need a surface that collimates the lights.
No. How about an arc lamp?
No.
Or you don't think you do with an arc lamp?
Okay, then show me a demonstration where you can replicate a rainbow indoors without collimating light.
Because
all the university papers that I've read about it disagree with you.
Okay, post one.
Okay, happy to.
Okay,
and we did. Somebody did post a video twice, I think, earlier.
No, the video shows a light source with a reflector in it.
Well,
that's not collimated light.
That's literally what a reflector in a light source is.
No, you just said that a mirror. You couldn't make it with a mirror and a light bulb.
They don't
So be more
use flat
specific.
mirror. Listen, brother, reflectors
Be
and
more
light
specific.
sources. Listen, man, a reflector and a light source is not a flat mirror. It's specifically built with a curve. It's built parabolic specifically to create a focal point that collimates the light.
Yeah. So what
Said
did you
it-
see in the
He said it
video?
like 3 times now.
You saw
Come on.
okay. You saw a light source and then like a flashlight or something, and then you saw a mirror on there.
Yeah, what's
or
on the end
something?
of that light?
I saw the type of light bulb it was, and I looked it up. It has a reflector in it.
Correct.
Yeah, Piggy,
Okay.
do you
A collimating-
agree with
a collimating
Wesley who
reflector.
just left? Do
Wait,
you agree with Wesley who just left, who said you can just use a light bulb and you can create a rainbow?
No, but I don't think that's what Wesley said. It depends on the light bulb, obviously.
He said a
'cause
test plan.
Witsit just said he looked up.
test plan.
Witsit just said he looked up a light bulb that would work because the light bulb is built in such a way that it could.
Well, no, I looked at the video. I saw a light bulb, looked it up, has a reflector in it. So, like a reflector that collimates light is not demonstrating that you can replicate a rainbow without a surface that collimates the light.
Yeah.
So when we're
somebody asked
outside,
me-
what is this?
Somebody asked
So
me,
when we're
can
out,
you? Somebody asked me, can you create a rainbow with a light bulb? And then I would say yes with that light
yeah,
bulb.
the answer is you can with specific reflectors. So then, if we're outside on Earth, what is acting as the surface collimating the light? We have an answer.
Oh, I mean, the sun comes in at a half a degree. It's
No-
the sunlight is already collimated, and we can measure this.
So you guys have to just beg the
Doesn't
question and
it
reify the
scatter
model.
the
Well, it's not beg the
No,
question.
it's not
It's
begging the
measured with
question.
it. For fuck's
You just
sake.
need
You
to
are
make
begging
a
the
pinhole.
question. Wait, how do you
It's
measure
fucking
it?
measured.
How do you
Pinhole-
measure
you
it?
make a pinhole.
Look at the
You can
sun.
do like a pinhole
To-
camera style.
Measure it.
Get a sheet
That
of
doesn't
paper,
measure
poke a
anything.
hole.
Yeah, it does.
Sure
It
it
measures
does.
the arc.
No, it doesn't.
What do you mean it doesn't measure anything? It measures how
What's
big
the
the sun is. It's a
what's
half
the
a degree.
measurement of the divergence of the rays?
Yes, the pinhole.
You can't measure it without knowing the distance to the light source and the divergence of the rays. Like that's
No,
how you
that's not
determine
true.
collimation.
What do you mean you can
Yes, it is
measure it?
true.
Let me look. I'm pretty sure. Let me look up Chat GPT. But I'm pretty sure if using a pinhole, you can determine how much collimation there is. I'll get back to you 1 second.
Ah,
Bro,
you guys
can
are
we just
exhausting.
can we just skip to Aries
But the
failure and
pinhole's
just dunk on these dudes?
the pinhole is also going to act like a lens, right? So it's going to change the ray divergence. So
Nope, it
there's that.
doesn't. Okay. Pinholes are not lenses.
It acts as a lens. What are you talking
doesn't.
about, dude?
It's an
doesn't act as a
aperture. What's an
lens.
aperture?
There's no
dude?
It's
like
an aperture.
lenses create a focal
What's
point,
an aperture, dog?
right?
What is focal length?
So
Wait,
so
wait.
you're telling me
Focal
when
length is
you
zero.
make a pinhole camera, there's no specified distance that would give you the best picture between the distance from the pinhole to where you have the film?
Correct.
No, it's an infinite focal distance.
Thank you, Paul Knight. I did these a bunch
No,
when I was
it's not.
I
It
couldn't-
distorts.
It's not.
The
I
further away
promise
you
you.
get from it,
I did
based
these
on
as
the
a
size
kid.
of the aperture of the pinhole, it distorts the image.
That's sort of it baked into it being a
Well,
pinhole.
yeah, geometric distortion, sure, but you can counteract that. So you're saying like a flat film plane is going to be distorted at the corners, right?
Yeah, obviously it's going to be distorted at the corners, but even through the center, you can't have a pinhole and then put your photographic film 350 feet away from where that pinhole is and expect to get an image.
Oh, I mean, actually, you could. It'd be very dark. It'd be a very long exposure, but there's nothing preventing that. It'd also be effectively a telephoto pinhole at that point. The farther away, the more magnified the image is on the film plane, and the dimmer it is due to inverse square law. But it doesn't get blurrier.
Dude, it
It
literally
at no
acts
point does
like
it
a
stop.
lens. It's not technically a lens, but it does the job of a lens.
Via an entirely different mechanism, so it's not going to have all the same qualities and properties. It's diffraction rather than refraction, primarily.
Exactly. Nobody said that it was refraction.
Right.
Let's get to
So-
an actual point here.
Another way you could, it's not really collimating light, but let's say you had a really bright bulb and then you went away from it, a mile and you put like the head of a pin up and then you measured the angle, like how collimated the light was that was hitting the edge of the pin, you'd find it was really collimated.
How would you measure that at all?
And that's what happens with the sun. Sun's big, Earth's really,
You
really
just
far
ignore my
away.
question?
And so the light that reaches the Earth, it's collimated just by nature of
You just
being
ignoring my
small.
question? How would you measure that? That's the question. How do you know that the sun's light is already collimated?
Yeah, you're begging the question. And by the way, let me help you guys out here. Another way to replicate a rainbow
Address
indoors.
what I just said instead of just saying you're begging the question. You say that like
You didn't even answer my
don't have an
question. I asked
answer.
you 3 times. Does he have me turned off or turned down?
Pinky, do you
know
have
I'm a mod.
peace
No, he's probably
muted?
ignoring you saying begging the question because you'll say it so often.
I didn't even say it.
That's what I
Hang
said.
on a second. Pinky, do you have Beast muted?
Oh shoot, I might have him muted. I'm sorry, Beast. I might have you
Why?
muted. Yeah, I do have this phone. Sorry about that.
Yeah, it's okay. Just gotta be careful muting a mod, but I asked you a question 3 times.
I
but
have
you didn't
Tora
respond.
and Galatrax muted.
That makes sense. I said, okay, how would you measure that when you brought up a light bulb a mile away from, and then you were holding up a pin? You would say it would be mostly collimated. My question to you was, how would you measure that? You didn't answer, and then I asked a follow-up question. I said, that is our point. How do you know that the lights from the sun is already collimated?
Yeah, I would just do the geometry on it. I would say how big is the light bulb? How far away is the pinhead? How big is the pinhead? And then that you could use those 3 things to calculate the exact maximum angle of collimation that's hitting the pinhead.
Okay, I can agree with that, but that's just a calculation. My question was, how do you measure that?
I mean, I think there's several ways you could measure it. You could go, like you're saying for the pinhead.
Yes, and then my follow-up question. Go ahead and answer my follow-up question, though. That's more important.
Okay, well, remind me the follow-up.
How do you know the light from the sun is already collimated?
Just through geometry. I don't
It's just
know.
based
I'm
on
not
the
saying I know it is. I'm just
ChatGPT.
saying based on
It
the
just
fact that
is?
all. No, I'm just saying like I take the inductive approach where, you know, everything like the predictions match all of the tests that we've done for determining the distance and the size of the sun. They make sense to me, and so
Okay. Other than
you could do
saying
the
it just
geometry on
is,
it, and that matches.
what are you talking about?
It's an inductive argument. It's the best explanation. The sun's distance and the sun's size and the Earth's size are the best explanation of what we see.
Okay, is it the only explanation, or will you concede that it's not mutually exclusive?
I don't think anything's ever mutually exclusive.
Okay, so can I just say something productive here? So, like, just so you guys know, you can also use like a glass of water indoors, and you can use light that's not collimated. Okay, so it can be divergent, like just normal light source, right? But what happens is whenever the light source interacts with the glass and the water, the exit point of the light that creates the rainbow, it's collimated in that very portion of the light. So it creates parallel rays at that very moment you see the rainbow. So still, it's collimated light creating it, even though the light source itself is not. You still need that physical container. That interaction between that and the water creates that slight moment that'll give you a rainbow, but it'll be like way fuzzier, etc., because the light is so divergent that's entering it. So there's no way to do it. I've already looked into every possible way. Like the very physics of rainbows requires it.
Dude. Okay,
I
real
might have
quick.
missed the earlier
Did you
part
see?
where are we debating whether the sunlight's collimated? Are we? I don't know. Maybe I missed the first part.
Oh
Yeah,
my
it's
goodness.
basically collimated. It's not perfectly collimated. It's still 0.5 degrees off.
Yeah,
for
but
some odd reason.
making a rainbow doesn't require
No,
perfectly
there are
collimated.
some light rays coming from the sun that are perfectly parallel.
It's inconsequential to the argument.
But they're with 0.5 degrees off. It's close enough to make it. Well, by the way,
No,
Witsit, I would like
no,
to
not
apologize.
no.
That's not what he's talking
There
about.
are some light rays that are coming from the sun that are perfectly parallel. A small percentage of the light coming in is across the Earth
Just on
perfectly
repeat.
parallel. Not
It would just be in
near.
like
A small percent is perfect.
it would just be in like random little areas, and part of it would even be like going at angles out away from the observer and stuff.
Yeah, but you don't see those because they're not intersecting the Earth.
That's
Way
not
But
what
they
ahead.
are
happened.
intersecting the
No,
Earth.
they are intersecting the Earth.
Yeah, the one coming from 0.5 degrees each side, right?
No, we're not
Dude,
talking
you
about
don't get
coming
it.
from the far edges. We're
Yeah.
talking about some light rays that leave the sun. If they're 10 miles apart when they leave the sun, they'll be 10 miles apart when
10
they
miles
hit the
apart when they hit
Earth.
the
It
Earth.
takes
That's
two
correct.
detectors to pick them up, but some of the very small percentage of those light rays are parallel, not near.
Yeah, I agree with that.
They are.
Which is inconsequential to the point, though.
And I guess with it to say what you said a while ago about you said we'd see rainbows everywhere or light everywhere, whatever you said about rainbows a while ago. I guess since every drop you could look at as every raindrop you could look at it as an individual point. Every point would only experience like a small divergence of light coming in, but two different
Raindrops aren't very
points
big.
could have parallel light coming in between the
Yeah,
two of them.
which wouldn't give us like a full rainbow, you know? So like your model will
Here's a
have to
good
claim
test.
for sure that the small portion of the light that intersects with the Earth because it's so big and so far away is effectively it's like close to parallel, and that
0.5 degrees.
creates a rainbow.
Correct. Very good. Welcome to the globe.
Welcome to the globe. Can you verify any of those assumptions at all?
Sure. Yeah, you can measure the sun.
How do you measure the sun?
Measure
You
the
look at
sun.
it, and you take and you measure the dangles to the sun.
That doesn't
It's
help you.
0.5 degrees. 0.5 degrees.
That doesn't prove it's 93 million miles away and the size you
Doesn't
claim it
need-
is.
doesn't
But
need to be 93 million.
864,000 miles in diameter or whatever.
That's not the issue right now. The issue is that
You actually want to.
Here's another test. I got another possible
Hold on.
test. Maybe
Was something important. I heard NASA Shill say "I Apollo," and then he got cut off. So what was
Yeah, I
that?
apologize between I was messed up, coherent, and collimated. So
Oh, okay. That
So
was
why do
your.
you keep saying that
sunlight
it's
is
0.5
coherent. It's
degrees,
not
NASA?
collimated. What?
Why do you keep saying it's point? You keep saying that it's light is near parallel instead of saying
Yeah.
some of the light is parallel. Why
Bro,
do you
you
keep
guys are
saying it's
still on this
0.5
topic,
degrees?
dude.
Yeah, because it's not perfectly parallel. It's about 0.5 degrees off. You're right. A lot of it is parallel, but not all of it.
Yeah. Okay.
there's a max. The 0.5 is the maximum. It's like the maximum divergence. That
Yeah,
Bro,
but
I went to Goon for 5 minutes. You guys are still talking about the same thing.
The thing is, if you want to take a half a degree in the sky, something that takes up a half a degree, if you don't assume it's 93 million miles away and add a bunch of like kind of ad hoc trigonometry, you just take that half a degree. If you take the 1 degree per 69 miles, then the sun takes up 34.5 degrees of the sky and thus of the ground, a half a degree, half of 69.
No, it's a half a degree everywhere. It's not half a degree here, and you can't add it to the half a degree there. That's not how it works out.
Talking about the angular size of the sun.
Still the same.
I
all
got a
over the Earth.
test. Like,
Within a day, it changes.
This might be mutually
According to Witsit,
exclusive.
even Witsit degrees, it changes 0.008 per day from noon to sunset.
I'm not talking about it changing. I'm talking about it just being the half a degree in the sky.
Yeah, it's always half a degree all over the Earth.
34 and a half miles, half of 69.
Yeah, which won't matter at all if you've made the measurement.
Okay, so this is my test. So I would think if the sun's close to the Earth, like 3,000 miles, then you would see noticeably a lot less collimation. The light would spread out more. So on the equinox, you get a person on the equator. You have them put a stick in the ground. This is not Eratosthenes, so don't crash out. Then you have somebody that goes 1,000 miles north, and they put a stick in the ground. And then you just check, and you see what would be predicted for highly collimated, like the
Where are you
globe
getting these
prediction.
3,000 miles away from? Where are you getting this number from?
1,000 miles north on the same longitude.
No. You said 3,000 miles, the distance between Earth and the sun.
Oh, I'm just making up whatever. Some people think the sun is below airplanes, but like airplane height up to 10,000 miles or whatever, but definitely not whatever you think it might be. Then, okay, so you do that.
No, because that's the position, is that it's in an apparent position where we don't know the size, don't know the distance, don't know the height.
I'm just going to go with Shane's claim that the sun is 3,959 miles away. You may disagree. I don't know. I don't want to debate that part. I don't think it's relevant to my test. So you have one person at the equator put a stick in the ground. You have somebody go straight north 1,000 miles on the same longitude. They put a stick in the ground. So if on the globe model, you're going to see no shadow on the equinox. Right? For both of their solar noon, you're going to see no shadow. If the sun is only 3,000 miles up, you're going to see a variation in the shadows. You could also do this we talked about this before, but this is one of the good arguments against the Gleason map, is that on the equinox, all the shadows go due west. They go along the east-west. Whereas on the Gleason map, they don't. So the sun, like the sun would cast a shadow that would.
This is like what you guys are every time. Basically, everything you guys do is mixing. Like you basically just take flat Earth and you just assume everything about the globe and light traveling straight, blah blah blah, and then try to do math.
Well, yeah, we do. I do assume light travels straight.
Yeah, exactly. So there you go. So you're mixing models together. So congrats.
All right. Well, if you don't think light travels straight, or you have evidence of that, would be you could propose that.
Do you guys always have to like argue against not our argument?
It's pretty simple. Like you guys, what's funny is they were like laughing at like, is someone else talking? I feel bad. Like I got a lot of people muted.
No, you're good.
You guys always it's funny they laugh at like us saying like apparent positions and there could be something like weird going on. It's like your entire model is like the opposite of ours. So like the physicality of your model is like craziness. Like all these different orbits and shooting off in different directions, and the Earth itself being a ball. It's like it's so much less crazy to think that light is just bending than the Earth is bending.
I mean, like I would say just propose a model for it. Like one of the models can explain lunar eclipses, for example.
But you don't need them like you want a model of like you want a model of the sources of these lights, right? That's what you guys believe you have in your model. We're not talking about like what we're talking about right now. For us, it's just the apparent visual hemisphere that you're seeing above you at different points in the flat Earth. That's it.
But real fast, because it's getting so lost in the sauce. It's getting so. Can anyone provide actual replication of rays that are half a degree divergent, creating a rainbow, please? Because it doesn't happen. So could someone please enlighten me? Or you guys think that's a thing?
You have to have it more collimated than a half a degree.
Yeah, from my understanding, yes.
Half a degree would be the maximum divergence.
Well, the reason that if you look it up, you know what the claimed proof of that is? That the sun does it. So like literally the claimed proof that you can create a rainbow at half a degree divergence is it has to be that way because we believe the sun does that on Earth, creating rainbows.
Well, but to Cole's point, it's not that's the maximum divergence. A lot of the rays are parallel.
It doesn't, brother, doesn't matter. The point is that like you can't have no. Is there ever a portion in time where there isn't divergent rays on the Earth? According to your model?
But that's like correct. But is there ever a time where there aren't parallel rays on the Earth, according to my model?
Those parallel rays can't be invoked to explain the rainbow because they'd be sporadically scattered throughout the sky.
No, they wouldn't.
Yes, they would.
Why? No, they wouldn't.
Yes, they would. They would be different angle. Dude, Cole's explaining that different angles.
What part of parallel do you not understand? When you can't say those parallel lines would be scattered and not parallel.
You don't seem to understand what Cole's even saying.
You don't seem. No, I do.
You're arguing against Cole at this point.
No, I'm not. I'll still
yes, you are.
Cole said. He said the maximum divergence of rays coming from the sun is a half a degree, but a bunch of those, there are many, many sets of rays that are perfectly parallel.
That's exactly what he said.
Yeah, but that's not the point. The rays that he's talking about that are parallel.
Cole, did I steel man you?
Yes.
Okay, yeah, because he leaves out the actual relevant point. Left lane, you couldn't be more lost right now. We don't need you to talk.
Most of the light rays that are parallel are the ones that are striking you, that you're looking at, that you see. Most of those rays coming at you parallel.
Wrong, actually. Your model claims that practically all of your model claims that practically all of the rays, the vast majority of the rays, are not technically parallel. They're just close enough to use them as though they're parallel. Cole is talking about, stop interrupting me. No, that's a fact. You want to bet $5,000 on it? Do you not know your model? Stop interrupting if you don't know your own model. It's annoying.
Get the lawyer. You want to
What
bet the
Cole is
money? Get
talking
the lawyer.
about, what Cole is talking about is that technically speaking, if you take any 2 points of the sun, right, because the light's going in all directions, you could take the same angle in relation to the other point and get a parallel ray. The point is that as it applies to the Earth, so you have the small little section of the sunlight hitting the Earth. Within that small little section, there's points here and there that have parallel rays, technically speaking, because the light's going in all directions from different points on the sun. That's what he's saying. So when you take that into relation to the whole spectrum of the light hitting, or the whole span of light hitting the Earth, that would be a very minor portion of it. It would just be little places here and there where that point matches up with this point parallel. It would be very randomized. It would not be across the whole sky. It wouldn't be the majority. It wouldn't even be remotely close to the majority. So what your model claims is that, generally speaking, your model doesn't even invoke anything to do with what Cole's talking about to explain rainbows at all. What your model claims is that because the sun is so big and the spectrum, the amount of light it sends off is so much bigger than the Earth, by the time it reaches the Earth 93 million miles away, just a tiny little fraction of the sunlight's hitting it. And when you look at the totality of that small section of light hitting it, the divergence is only half a degree. It's negligible. So for intents and purposes, it can be treated as parallel. That is different than what he's talking about, which are literally parallel rays based on 2 different points on the sun. Those are not the same thing.
So if you've got a 1-inch dowel, you've got a 1-inch dowel. You've got a 1-inch dowel casting a little shadow, and you see a little fuzzy edge on either side of that shadow, just a little narrow fuzzy edge. That fuzzy edge represents the beams that aren't parallel. The 1-inch wide shadow is the light that is parallel.
Yes. So all across the Earth, there are parallel rays, not just here and there, everywhere. You will have parallel rays coming in.
Again, yes, it would be everywhere, quote unquote, but it would be the minority of the rays.
Yeah, the very small
Okay,
part.
so that's my point, though. If it's the minority of the rays, you can't have a rainbow, right? Because you have from point A to point B of the rainbow, the whole spectrum of that rainbow, the whole width of the rainbow is not going to be getting hit with literally parallel rays from the sun in your model, right? Because it's a minority of the rays. What you have to claim is that a rainbow can be created by the sunlight because it only diverges out half a degree maximum, and that's collimated enough for intents and purposes, it can be considered parallel, and rainbows can be replicated, or rainbows can be created with light rays that only diverge out half a degree. That's what you have to
I don't know the
Welcome
answer
to
to
the
the
club.
lab you keep referring to it, but what's the required collimation in a lab?
Well, that's a good question. From my understanding, you're talking about arc seconds.
Okay, I just looked it up and it says the practical ranges are under 0.5 degrees is a sharp rainbow. 0.5 to 1 is a clear but somewhat broadened, and 1 to 2 degrees, you get substantial color overlap.
Well, I just looked it up and it said that the way that we set the parameter of 0.5 is based on the fact that rainbows happen on Earth. Therefore, we know that because the sun diverges that much, which does not help us in this conversation, right? So if you want to drop a paper where they actually replicate a rainbow with the distinct colors, that's what a rainbow is, like what we see on Earth. No one cares about like a conglomerate of fuzzy colors you can't make out. Like an actual rainbow like we see on Earth. If someone wants to show me them replicating that in a lab at 0.5 degrees, because what I just looked up, it's talking about how if you use a light source with 0.5 degrees or greater, you actually have to introduce an additional surface to collimate the light further to get a real replication of a rainbow.
Yeah,
You show me a rainbow that's not fuzzy.
If you got that, post it. I'll look up and see if I can find one. Because I mean, like arc seconds, so that's a huge difference from half a degree.
Yeah, no, I mean, and I'm not going to say any specific because there's like a range of it, right? Like I know that the papers that I had looked at, they were insanely precise. They were using they were able to control it down to 0.05 arc seconds, which is insane.
Yeah, but I mean,
Absolutely
that doesn't mean that that's the only, you can only make a rainbow at 0.5 arc
No,
seconds.
I didn't say that. But my point is that at half a degree, they're having to introduce additional surfaces to it to collimate it further. So,
Yeah,
and
just
like literally, it straight up says.
where they have to do it at 0.5. They
Do you think
require
it's just a coincidence that if you look at it like it says, rainbows can be created up to a half a degree? Just coincidentally, the maximum of the rainbow is what the Earth supposedly experiences sunlight.
Mine's set up to 2 degrees.
Well, actually show me that, right? Because when they say it's like blurry or whatever, cool story, show me the rainbow because it has to actually replicate what's on the Earth. That's not what I found when I looked it up.
Rainbows. I mean, you see blurry rainbows on Earth all the time. I think a lot of the rainbows I see, they're not crisp like what you see from a prism.
But the reason that rainbows are like not always like completely visible on Earth is because of like something between us and the rainbow. It's because of clouds or whatever's blocking the view or partially blocking the light. It isn't the formation of the rainbow itself.
I don't know. I have picture. I can post pictures I took personally. There's no clouds between me and the rainbow. Just me and the rainbow.
The ones in labs are bright because it's in an otherwise dark room, usually on a dark background.
Well, it also doesn't
get
normally
real
have
sharp
like
and crisp.
mist and clouds and things between the observer and the rainbow. Do you guys agree that if you have a rainbow and you're viewing it through like mist, the light from the rainbow has to travel through all the mist between you and it, for example? It's obviously
but like if you look at the picture that NASA still posted, I can see details of trees through whatever mist, and then I see a blurry rainbow.
Yeah.
So whatever the mist is doing, it's not affecting the trees, but the rainbow's blurry.
It's not a tree and the light of a rainbow are not the same thing, man.
But they're both affected by mist. They're both going to be made blurry by mist to the same degree, right?
No, because the actual rainbow itself is being created interacting with droplets.
Yeah, they're both light. So why would one be affected by it, the other one not?
It's not that they wouldn't both be affected. It's that they wouldn't be affected the same. The actual light is already being refracted and diffracted by the rain. You're viewing diffracted light.
Argue that. I don't see how you would say the droplets make one thing blurry. Some light that's coming to my eye, it makes it blurry. Other light that's coming to my eye doesn't get made blurry at all by the same droplets that are between me and that scene.
If you remove the rain and the mist, can you show me the rainbow without the rain and the mist? I can show you the tree.
Well, can
you show me the rainbow?
I don't see mist and rain in NASA's picture. It's pretty clear.
So there's a rainbow with no rain?
You're saying there's a rainbow that has no rain in the sky?
I mean, there's a picture. 15 after the hour, you can go look at it.
Oh wait, then what's the mechanism for the rainbow on your model?
I mean, there can be water droplets in the air and not rain. Correct.
All right.
So you can see it. You can see it in like a mist or whatever.
Okay, so we're being pedantic.
So are we saying the sun is not half a degree wide, or not?
No, I'm saying that if we try when they try we try to replicate it in a lab, that it says that the way we know the maximum divergence that'll still make a rainbow is half a degree is because the sun does that, which definitely doesn't help us in this conversation, right?
Actually, it does because we know the sun is a half a degree wide.
No, does someone want to show me them replicating it in a lab without introducing an additional surface to further collimate the light?
In a lab, in a bucket? Yeah, okay.
Can you show me a bucket of Lagrange? Bitch.
I mean, you could also post yours that shows that in the lab they had to use an extra something or other to collimate the light, even though it was already at a half a degree.
Well, I already told you that. I already told you I just googled it. I already told you I just googled it, and that's what it said.
So just paste the source. Hey, give me the source link and then paste that in chat.
It was just an AI overview that answered the question that way.
Well, I'm sure there's a study that it got it from. So just.
But you're claiming that it exists, right? You're claiming that it exists. I read the papers where they collimate all the way down to like 0.05 arc seconds. We know we need collimated light. Whenever you take like a typical flashlight that's greater than half a degree in divergence, so say you have like a flashlight that's like 3 degrees divergence or whatever, say even 5 degrees, 10 degrees, we know we have to introduce other light sources. And the only portion, if I take a 10-degree divergent flashlight and I try to replicate it indoors and I use a glass with water, it's only the very small section of the glass and water that makes those light rays parallel that we see a rainbow. So it's like,
so you can't provide your source. You can't provide your source. By the way, I looked it up. It says above 2 degrees, you're going to get washed out spectral glow. So that appears to be the cutoff. So yes, if you have a flashlight,
why can't you show a source? You're claiming it's possible. I've already demonstrated my claim.
I haven't claimed that I had a source. You claimed you had a source, and now you're running. You are refusing to show it.
No. You're a liar. See, I knew it would only take a couple minutes before you lied about something. I just said very clearly, right, that I just looked it up. I asked, and then I got the AI overview. The source I have. Are you disputing that universities have replicated it with highly precise collimators? Are we disputing that now? Okay, so that's what I claimed I had a source about. So when did I claim I had a source that said that they show that at 0.5 degrees or higher, they had to further change it? Or did I say that's what the AI overview said?
In labs, you said in labs that if they're at 0.5 degrees, they have to use an extra collimator, and they say, Google says that the only reason why they say that we can create a rainbow at 0.5 degrees is because the sun does. That's
so where in what you just repeated did I claim I had a source? I'm just telling you what Google said.
Maybe you didn't say that.
Okay, but you knew I didn't, and you intentionally said that to be misleading. So, but this is the point, right? You're shifting away anyway. You're shifting away anyway. You're claiming that it's possible. Your whole model. No.
Literally,
stop interrupting me, dude. Stop interrupting me. We said, look, you have to collimate a light source to replicate a rainbow. We're saying, well, yeah, flat Earth, there's a container. We have it collimating the light source. We have a rainbow. What do you know? It also would make it not change angular size. It would make everything be in an apparent position, all internally consistent. We have a perfect mechanism for the situation. You guys have to support your claim in your model, which is that the light can diverge up to half a degree from the sun and still create a rainbow. Why are you trying to shift the burden to where I need to show you that isn't possible? You need to show it is possible first.
Okay, my source is also AI, and it says 0.5 degrees and under, you get a sharp rainbow. 0.5 to 1, you get a clear but somewhat broadened, and 1 to 2 degrees, you get substantial color overlap. Okay, you should be perfectly satisfied with that.
Why? I've actually read the university papers where they've been replicated with collimators all the way down to 0.05 arc seconds.
Yes, sharp rainbow. Okay. I'm guessing it's an extremely sharp rainbow. Good job.
Okay, so I tried to Google, I tried to then look it up for you and find where it's been done in a lab with half a degree, and I couldn't find it anywhere. And then whenever I found what the AI was answering, it said that if they use a half a degree, they have to use something else to further collimate the light. So you're claiming that isn't true. So then, okay, that's cool. But again, we're back at the point where, do you have any actual empirical evidence? Has that been replicated on Earth, or are you just going to blindly believe it because it has to be true because your model says so?
Well, are you going to blind believe that they need an extra collimator at 0.5 degrees?
Or no, I don't have to blindly believe anything. I don't have to blindly believe anything. Is this your claim?
I mean, my claim is that 0.5 and under, you're going to get a sharp rainbow. That's what my AI said.
Okay, so can you show me 0.5 degrees and under is such a huge spectrum, right? So first of all, that's a problem for you because you claim that the light, stop interrupting me. First, you guys claimed, oh, the rainbows on Earth aren't sharp. I see them blurry all the time. And now you're claiming that 0.5 degrees and lower give you sharp rainbows. So now we're just, which one is it, right? Is it sharp rainbows at 0.5 degrees or not sharp rainbows?
Well, obviously the light droplets, right? That's what you said. Light droplets are going to make it blurry.
Okay, so now we're using my explanation. Okay, sounds good.
Why not?
So,
Do you
okay, it's just
are you
funny. Well,
backing
because
off
you
of your
disputed it
explanation?
5 minutes ago, as much as far as saying the trees would look different. So whatever. We're back to the point where the globe claims the sun is 93 million miles away. That the light rays are effectively parallel because a small section of the sun light rays hit the Earth. That they diverge up to 0.5 degrees, and that can create a rainbow. Do you guys have any evidence of that? Can that be replicated inside? Because obviously we can't go outside and just point to the rainbow and say this is proof of it. And when I read Google's overview, it literally said because the sun diverges up to 0.5 degrees.
Yeah, I read ChatGPT's and it says it's totally fine.
ChatGPT is the dumbest AI.
Okay, I'll ask Claude. You said yesterday Claude's the best, better than Google, so I'll ask Claude.
So you guys can't, I mean, I can't find it ever
Can
replicated. I'm
you
guessing that you
make
guys can't find it
a
replicated. So
rainbow with 0.5 degrees collimated light?
ChatGPT says
it's gonna
Provide
say
a
yes
source,
because
please.
again, it's gonna say yes because they believe that the sun creates rainbows and they know it goes up to 0.5
No, your
divergence in
Google
your
just
model.
said no. Your Google just said no. Your Google just said no. You
No,
can't.
my
You have to
Google's
put in an extra. You have to put in an extra thing to do it.
first of all, what my Google originally said is we know that you can create rainbows up to 0.5 degrees, meaning it invoked 0.5 degrees as the highest, like the highest level of divergence, the maximum divergence, because that's what
because
the
of the
sun
model.
does. Yeah.
Well, mine said 2 degrees. Let's see if Claude
Dude,
agrees with
literally,
you or me.
ChatGPT does that shit so much. If you look up like where's the farthest north you've seen that there's been an iceberg, it'll say the one from Titanic. It's like, are you sure that happened?
All right, we'll battle of the AIs. What's the max collimated
Or
light that
farthest
can
up.
create a rainbow? Let's see what this says. It's still running the other one. All right,
Yo,
it says at 2 degrees, colors overlap into white. 0.5 degrees, clearly colored. And I got some sources. Let me see if I can find one.
Yo, can someone untime out Electric? He's been really dying to come in this debate. Also, Osco got banned. How am I not banned and Osco's banned? Come on, it makes no sense.
Nosko's not banned. He left, I think.
Oh, he got timed out and then he left. All right, you're right.
So look, I'll just tell you what's going on with Google right now. So I'm trying to find it for you for whatever reason you guys won't look it up. I said, can you cite a test in a lab that replicates a rainbow indoors with light diverging half a degree? And it says, yeah, in laboratory demonstrations, replicating a natural rainbow indoors requires matching the sun's angular size, 0.5 degrees. Physics apparatuses such as the acrylic cylinder setup published in the American Journal of Physics, the rainbow in the drop, utilize collimated white light sources designated or designed with a specific beam divergence near 0.5 degrees to project and analyze higher order rainbow angles correctly. I'm like, okay, awesome. So then I click on it. It doesn't say that at all. I say, none of those sources show half a degree replicating a rainbow in a lab. You are entirely correct, and I apologize for the error. The previously cited American Journal of Physics paper does not contain an experiment using a light source with half a degree beam divergence to replicate a rainbow. And then it says the requirement of a 0.5 degree divergence angle comes from the actual physics of the sky, specifically the angular diameter of the sun as seen from Earth, which spans exactly half a degree. However, indoor laboratory tests, researchers do not intentionally dial in a 0.5 degree divergent beam to study rainbows because doing so actually makes the indoor rainbow worse. Because the sun spans half a degree, every single color band it projects through a raindrop is also blurred out by half a degree. This causes the colors to overlap significantly in nature. When physicists study rainbow caustics or higher order bows indoors, they want to eliminate this overlap to see the sharpest data possible. Instead of a 0.5 degree divergent white light, labs explicitly use highly collimated narrow laser beams, 0 degree divergence. So that's very convenient, isn't it? So they're just assuming it must exist and they're not replicating in a lab. This is what I said at the beginning, though, which is when they actually replicate in a lab, they use like highly collimated light. So it's like what that amounts to is that we don't have a physical demonstration.
Let me respond to it. Your source didn't say that you can't create a rainbow at 0.5 degrees.
No, what it says is that here's a paper that does that, and then it says, "Oh, never mind, you're right, I'm wrong. It doesn't do that," and no one ever does that.
And then it said they in a lab they don't do that because remember it said the 0.5 degree divergence also creates a 0.5 degree divergence between the bands, and it creates blur.
So you cut me off to like repeat what I read?
Yeah, you can create a rainbow at 0.5. You can create a rainbow at 0.5 degrees. It's blurry.
So you cut me off to repeat what I read. So I went and gave you your best answer. Then you cut me off to pretend you're teaching me the answer by repeating what I read. That's just weird. But anyway,
well, I don't think it didn't sound like it. It didn't sound like it sunk in very well.
Well, it definitely did. I was about to make the point based on it, and you interrupted me to repeat it as if it was your point. So the point is, what that amounts to is we don't actually have physical replicated evidence of a rainbow being created with half a degree divergent light beams. It's just assumed to exist because it has to, because the model says that's what happens.
No, you did not understand your source. Your source said you can create a rainbow at 0.5, but it's blurry. So in a lab, they try to get the collimation down to 0.
It's saying it exists is because it assumes it has to exist. So I don't care that it says, yeah, you can do it.
That's your words, not that's your words.
It literally does say that. It literally. So you're the one that didn't listen.
Read it again. Read it again.
Okay, don't worry. Don't worry. I will. You're the one that didn't listen.
It's possible.
Pretty funny. The requirement of a 0.5 degree divergence angle comes from the actual physics of the sky, specifically the angular diameter of the sun as seen from Earth, which spans exactly half a degree. So the whole assumption that it does create a rainbow is based on the model. So this is the point, though. When actually pressed on it, it says, oh, I can't find anywhere they've actually done that. Now, you would think, though, that if you're going to try to actually study rainbows that happen in reality in a lab, that you'd replicate the actual parameters of rainbows on Earth according to the model. So isn't it interesting they don't do that?
Okay, I'll go look now. If I find one, how are you going to respond?
I would just look at it.
And then what? If they did create a rainbow at 0.5 degrees, then what?
I would admit that you can create a rainbow at half a degree.
Amazing.
Why do you guys always say that, dude? There's so many times where they say that, and we don't ever get any. Like I haven't gotten a video of Cavendish that you can actually prove, like you can actually see a noticeable change. And
let me just reiterate my point here. Like I've repeatedly have said, I'm not claiming for sure you can't. I'm saying you're gonna have to provide evidence for it. And I said, even if we set aside the claim of exclusivity, that isn't the point. The point is that you guys cannot. First of all, we have a mechanism that explains it, and that mechanism predicts that the angular size of the sun wouldn't change and that everything would be in an apparent position. So you guys can no longer make the claim that on a flat Earth, the angular size of the sun has to change. That's the actual argument. It's turned into, I need to debunk your claim that you can't prove and reify and assume and then affirm the consequent or whatever. But that wasn't the actual point of the conversation, right? The point of the conversation is, what do you know when we're trying to explain the 24-hour sun and the star trails in the south and the divergence at the equator and the eclipses and the counter rotation of the sun inverted and the optical phenomena we see in the sky being in an apparent location? It falls right in lockstep naturally with the implications of collimated light. which is what we know we need for a rainbow, and the apparent size of the sun wouldn't change. So our model is coherent and predicts and explains what we see in the sky. It's your turn. And best case
Sorry, my
scenario,
wife.
you'd have to say that
Oh.
the observation of the sun not changing angular size, rainbows, and all of the apparent locations observed on Earth are not exclusive either way. That's like the best you can do at this point.
Well, I don't think there's a. I don't. We didn't go over like in flat Earth.
You guys
what
can bring back
collimates
an
the light,
ether
but
ether
I
around the
definitely
globe.
don't. I think just saying we have a dome that collimates light is that's pretty weak.
Okay.
Or a kaleidoscope.
Okay, that's what's up. Well, if the best
Yeah,
rebuttal
I mean,
is
like,
that's
someone on
kind of
mute,
weak,
Electric.
then you know.
no, it is like, or just show us the physics for how that works.
Well, he just literally replicated a rainbow with a dome a second ago.
Did the light collimated?
Yeah, literally. Well, how do you create a rainbow without collimated light?
That's a great point. I guess it would have to collimate at some point.
Yes. So he showed us a rainbow using a dome a few minutes ago.
Because he made a rainbow using a dome.
Yeah.
What's the conclusion?
That your claim about how
was the light source inside or outside the dome?
I'm pretty sure it was outside.
Doesn't matter.
It doesn't matter because we're
It does matter.
It doesn't matter because we're invoking layers.
I don't actually just want to. I'm curious to know. So the light source was
does
outside
matter.
the dome. What was the
It
light
doesn't
source?
matter.
It does
What was
matter.
the light source?
I think it was outside, but it doesn't matter because we're invoking
doesn't matter?
layers. Because
It
we're
would have to be
invoking
outside,
layers.
Otherwise,
Oh, you're
it
invoking
would have to be
multiple domes
outside.
now?
Otherwise, you couldn't. Hold on, NASA. Otherwise, you couldn't claim that it was the dome.
It
was
would be
collimating
outside the
light. What was
lowest
the light source?
layer.
What
It would
was
be
the
outside
light
the
source?
Multiple domes.
And
now.
then what
How
was
many?
the
a
light source?
flashlight. I think. I don't know.
An
How many domes are there?
uncollimated flashlight?
I don't know. You'd have to ask him.
Oh my gosh. So a collimated flashlight, I'm just gonna assume. I saw something with the clouds that was.
But do you know? Wait, time out. You didn't see it, so I would assume you should not talk about it. The point was that the rainbow perfectly.
We'll get the
The
details.
rainbow took the shape of the dome, so it's not the same as some like chubby guy squirting some water hose in his thing 10 years ago, and then using a light with a reflector, and it's showing a small little portion of a rainbow. It's a domed rainbow underneath the dome of the sky, and it's perfectly depicted as that dome shape right underneath the dome that created it. So, but
where's the video so we can get the stats on the flashlight? But you agree if the flashlight's collimated, that completely sinks your argument, right?
No, it doesn't sink the argument because the shape of the rainbow took the shape of the dome. So there's obviously an additional collimated effect from the dome itself, or it wouldn't take that shape. But what's even
but not all.
You could do it. You
rainbows
could
are
do
dome.
it for sure with with like a light bulb outside the dome.
I don't know. I mean,
it'll collimate right up.
I don't
Not all
know, but
rainbows
one thing's for sure though, if you have anything that's being like reflective and curved, so a reflective surface that's curved, of course it's going to collimate it without whether the light source is collimated or not.
But the dome isn't curved. Or it's not reflective. We know that.
Wait, no, that's Joe Hanvey's model has a medium inside the dome that acts as a reflective surface. Not to mention that there's the additional explanation that the dome itself could be a reflective surface, which is how the scriptures describe it as like a mirror, a cast iron mirror, right? So
it's not very good at reflecting. When we shine stuff up to it, it's not very good at reflecting.
Wait, you say it's not very good. Do you guys know that reflectors and light sources that are used to collimate the light sources are parabolic and have a curve?
Okay.
So
do you
can
want
we see through this
to
mirror?
take a friendly wager on whether his light source is collimated?
No.
Why not?
Because I wouldn't be surprised if it was.
Okay, so why why would you wait, what was that? It was?
It was. It's a collimated flashlight. Yeah, of course. It's got a reflector in it.
All right, game over. So yes, it's a bad example.
Why is it game over?
I said earlier, not game over, but you can't say the dome collimated the light when you're using a light source that's already collimated.
Wait, no, are you disputing that a curved reflective surface would collimate light? Yes or no?
I don't know. I have no idea.
Okay, well, that's what reflectors are. In flashlights, the reflector is a curved parabolic reflective surface. That's what they are.
Yeah.
Okay, so what do you know? Everything perfectly matches up on our side again.
Yeah, but that's the light inside. Like for a flashlight, the light's inside the curve, the parabolic curve, not outside the curve.
Yeah. Okay, good
Which
thing
works
that we're
better for you
talking
'cause
about a layered dome.
Okay, well, when you
many domes
get
are
the
there now?
demo worked out where it's an
7.
uncollimated light
7
inside the
domes.
dome, which that's every model I've ever seen puts the sun inside the dome, not outside, then I think we're getting closer. All right, I'll see if I can find this paper, but
all those models
I
are
say
wrong in
like
my opinion
your
anyways.
claim of like we have a model that has light and it's collimated through the dome and it works for everything. Absolute BS, and I think you knew it because you wouldn't take the
How
bet
is it
on the collimated
BS?
light
It
source
would have
because the
to
light's already
collimate the light.
collimated.
It
Because
would
the light's
have to.
already
It doesn't matter.
It does because like a light
Okay, how about
bulb.
you want to
I've
talk about
never
a
seen.
friendly
Have you ever
wager?
seen a flashlight? Have you ever seen a flashlight where the light bulb is outside?
Wait,
outside of the curved reflective surface.
Do you want
And
to take a friendly wager?
Is Joe Hanvey's bowl a reflective surface?
I don't know.
Is
That's
it a
what I'm
mirror?
saying to you. That wasn't my argument, was it?
Exactly. Okay,
That
so
wasn't
maybe
my
don't make those
Stop.
strong
Oh,
claims
you
about your
guys always
model.
do the same thing. You don't actually have a good point, but you want to say it and then not let the rebuttal come out so that you can take a fake victory lap. It's super weird,
Oh, the
right?
irony of you saying that,
Right?
Witsit. The
Okay, still
fucking
made my
irony of you
argument.
saying
Still made my argument. Still made my argument.
The
I
fucking
didn't hear
irony
you.
of you saying to
All
talk
right, I'm
over
gonna
people
find the
and then take
paper
a
on the
victory lap.
0.5.
Okay, can't still make my argument. I'll say it again. So it doesn't really matter. It's inconsequential because if there was a curved reflective surface, it would collimate the light. That's a fact. Do you agree or disagree?
If the light was inside the dome. So let's see that model and then we can evaluate it. But as for right now, you can't declare some victory when you have a pre-collimated light source outside of a dome shining in and saying that
Wait,
solved it. It doesn't.
actually, I can go ahead and claim victory because it's known physics that can't be disputed. If there was a curved reflective surface, it would collimate the light. That's what it does.
Not from the shining from the outside in.
It's inside layers of it.
Is the light inside of the dome in Joe Hanvey's model?
It would be inside and outside. It wouldn't
It would be
matter.
inside and outside.
Yeah,
Do you not understand
layers
that?
of dome. Apparently, there's multiple domes. According
I don't
to
think I might not. I might not. I assume
If there
he had
were
the
if
light.
there were
I'm assuming he had the
multiple
light.
layers to a dome, would the sun and the sun was in one of the layers, would it be inside or outside the dome?
I don't know. Is that what Joe Hanvey's model is? He has multiple
Hey,
layers.
answer my question.
I've got a picture up right now of a diffused light source dome collimating, creating an azimuthal dome view with a terminator line, day and night, and an apparent sun.
There you go.
Okay, what's the light source?
It's a diffused flashlight where I diffuse the light.
Okay, but that it's collimated.
He diffuses the light.
And it's as viewed from outside the dome, right? Outside looking in.
Yeah, that's outside looking in.
Okay.
Any pictures from inside the dome? I mean, we live inside the dome apparently.
Are you guys claiming that apparent light source wouldn't be seen inside the dome?
I don't know.
Are there
I need
no?
some pictures from inside
How
the
do
dome.
you not know?
Well, we need some pictures from inside the dome to verify that.
Can you guys explain to me why it wouldn't be viewed inside the dome?
Model.
Well,
Hold on,
you look
Joe.
from outside.
I have questions about for Joe. Are there multiple layers to the demo that you just showed?
No, it doesn't have to be.
It doesn't have to be, but I can put layers in, and I get the same thing. Whether I put the lights inside, whether I project them from outside underneath, whether I put extra layers in to represent layers of the Atmos or take them out, whether I put a personal azimuthal dome in a physical personal azimuthal dome in there or not. Like I said, when I put the diffused light inside, it collimates into that azimuthal dome view, giving a terminator line, day, night, and an apparent position of the sun. Like I can do star trails, I mean, inside, outside, above, sideways, all kinds of different ways.
How do you get a terminator line inside with a diffused light source?
I just showed you in the picture.
Dome optics, dude.
You showed me in the you're saying the one that you just shared.
The picture
I thought that was
just
with the
had
light outside. I thought that was with the light outside the dome.
No, that was the diffused light source inside the dome.
So it sounds like he's got a lot of the model that you guys asked for. Can you guys show us a little vacuum chamber with little balls shooting around orbiting each other?
No, we can't.
Yeah, orbital mechanics inside a vacuum. We'll get on that.
Well, I
in
mean,
a bucket in the lab.
that's what a model is.
Yeah, in a
right?
bucket in the lab, in the Earth's gravity well, we'll get balls orbiting each other. Thank you.
You should be able to replicate that by countering the Earth's gravity.
Countering your. How do we do
Hey,
that?
just
Witsit?
get an electrovitic,
Magnet?
like maglev thing in there, and then
maglev. Right. Because
Right. Yes, right.
Because electricity is what? Magnetic or
dude, how about in the
electric?
ISS? In the ISS, try that.
In the ISS.
They supposedly did replicate orbits in the ISS with electrostatics, and what he did was take a needle and he created the static, right? And they took water droplets that supposedly revolved around it while he was clearly on a vomit comet. But the problem was what happened with the water droplets is they orbited the knitting needle and they kept getting closer and closer and closer to the needle until they popped.
Yeah, they weren't going fast.
They what? Are you claiming the planets are getting closer and closer and closer to the sun?
No.
Are we getting further away from the sun?
I mean, like slowly, I think, right?
Well, I think we're going away from the sun,
Slowly.
but we're not going towards the sun, though.
That's correct.
Okay, so then you can't even replicate. You can't even replicate orbital mechanics.
Orbital mechanics, which you know nothing about, apparently.
No, orbital mechanics makes the objects get closer to the
Well,
object.
not with electrostatics, at least.
Well, static electricity is the same as gravity, but weaker.
Incorrect again. Nice try.
Wait, why is it not?
It's a different force.
Okay, but what's the difference?
One's based on gravitation.
Polarity.
Yeah, but what's the difference with the net effect?
You can repel with electricity. You can't repel with gravity.
What's the difference with the net effect of orbits?
You can repel with magnetics.
That's not relevant at all, though.
So they're different forces, but they're going to act exactly the same because they're different.
No, they're not different because it's attractive. It's attractive. It's attractive in the demonstration. So for intents and purposes of gravity, which you claim to be attractive, even in relativistic, you claim it's a force that's not a force, can be treated and thought of as a force that's attractive, whether Newtonian or Einsteinian, you have the attractive component. If you take the charges to be opposing, creating the attractive version of electrostatics, then in terms of physics and mechanics and dynamics, it would be the same. You believe we're drifting out away from the sun, so you cannot even in theory replicate the orbital mechanics you claim in your model, even when we grant you static electricity.
What would happen if something wasn't moving at the Earth's speed? If it was moving slower than the Earth at the Earth's distance, what would happen to it?
I don't know. What would happen if unicorns popped up out of the Earth every morning to wake me up?
Come on. You say you know orbital mechanics, so tell me.
What would happen if we were moving slower?
Yeah, what would happen if the Earth was moving, say, slower? What would happen to us?
We would get further out away from it.
Incorrect. Try again.
Wait. You're saying we get closer to the sun?
Inwards with it, yes.
Okay, so then why are we going out away from it?
Now, how would it slow down?
In your well, we have to make it up. We wouldn't be able to do this. But in your electrostatic thing, I bet my guess is that the droplets were not moving fast enough to maintain their orbits, if you will.
They were moving way faster in proportion to the needle than you claim the planets move.
You can show me this, and you have measurements.
Yeah, just look it up. Don Pettit.
Oh, and I need to look
needle.
it up now. Right.
Oh my god, he's my favorite NASA astronaut.
You can't look it up. I really need to do it for you. Don Pettit, kneading needle. I got you.
I need to do your research again. Got it.
No, it's your research.
There's a Teflon needle. I think you'll find it with the term.
Needle orbit. There it is. There we go.
Don Pettit, my hero.
They destroyed that technology, and it's a painful process to build it back again.
Okay, I'm dropping in live stream text since you can't type 4 words into YouTube for whatever reason.
I found.
I want to have Don Pettit's children.
So anyway, it's just kind of funny, right? Because like you guys act like it should be impossible to replicate. It should absolutely be possible to replicate it. Like you can get a vacuum chamber. You can count. Are you disputing that you can counteract gravity?
But you want it to work with gravity, or do you want it to work with something
No.
else?
I want you to just to even show the orbital mechanics you claim, because you claim that an object can free fall and change direction in orbit perpetually, which defies every aspect of replicated physics known to man. I would like for you to demonstrate that's even possibly real. I don't even care what causes it, what force you invoke, or how you interpret gravity. I just want you to show me that that mechanics is even possible.
So you're disputing orbital mechanics now. Got it.
I'm disputing an object can free fall, changing direction perpetually. Yeah. Because that doesn't even make any sense. It's retarded.
Right. Because of your incredulity now, that means that all of
No,
orbital
no.
mechanics.
No, it's not incredulity. It's based on all
Yeah.
known empirical demonstrated physics. You're claiming something else. It's basically special pleading. Do you know what special pleading is?
Orbital mechanics. You think that orbital mechanics is wrong?
No,
Of course,
we can
it's
have.
wrong, you idiot.
Yeah, like your version of orbital mechanics is a made up thing. It's special pleading. Do you know what special pleading is?
Special pleading. Got it.
It's claiming the
Does
exception to a
does
universally
Hanvey's
accepted
model
principle.
have some orbital mechanics in it?
What's up?
Does Hanvey's model have orbital mechanics in it?
Probably not.
What? Wait, time out. What is the relevance of that?
Just you guys are building the model, and people want to know why.
Oh, we could easily.
Why the
We
moons
can.
of Jupiter? Why the moons of Jupiter go around Jupiter the way
You mean
they
why
do?
are there shadows on Jupiter?
Just
Shadows
why the
on
moons
Jupiter.
go. You can watch the moons. You can watch the
You can
moons
watch the
go
moons
around.
cross and see the shadow. But
I mean, you can see shadows. You can see shadows.
Or you can see the moon
And
itself.
moons. You can see moons and shadows.
You can see shadows. But this is the
You can
thing,
see
right?
the moon
And do you
itself
disagree that
too,
you can see moons?
casting the shadow.
If
Wait,
that's what,
Witsit,
if
do
that,
you agree that you can see moons of Jupiter?
yeah,
Are
of
you
course.
okay? So you can see
See them
moons and
casting
shadows
shadows.
of Jupiter.
No. You can't see
People
moons.
want
You
to
can
know.
see
People
little,
want to know what's
circles that
happening with that.
you can see
Yes,
little
little
circles that
circles, little spheres.
you stop interrupting me. You can see little circles that you call moons, which are a cool story. But you're asking if we can replicate orbital mechanics. We can
No,
absolutely do that. Stop interrupting
no.
me. Our model
Make
can
it easier.
absolutely. Our model is so superior to yours that we can show multiple different things that could cause orbital mechanics.
Really?
That you,
Show me
yeah,
orbital mechanics on the flat Earth. Show me the map.
magnetic levitation.
Show
Literally,
me
it
the
could
map.
just be. It could. Okay, what? Show
Bro,
you the math
I
of a
literally have
Show me
rotating
a
flat
magnetic
Earth.
field.
made, dude. This
Show
is
me
easy.
flat Earth orbital mechanics, please.
Yeah,
Super
we have
easy. It's
we
just
have real forces we can use. We can use any kind
Show
of
me
maglev
flat
tool
Earth
you
orbital
want.
mechanics. No, show
Yeah,
me the
not like
ISS.
just a,
Show
not
me
like
the
a.
ISS
It's not
orbit.
hard for us. You're the one
Show
that says
me.
you can't do
Show
this.
me.
You guys
Show
admit you
me.
can't do this. We can do it.
Show me. Show me the ISS orbit on a flat Earth using orbital mechanics. Show
Highly
me the map.
specific.
okay.
I
So
picked the sunlight. Come on, show it. I want
okay,
to see the map.
so I'm gonna answer you. Can you shut up? You think it's a slam dunk? It's definitely not. Your model can't explain the ISS's orbit over a globe Earth because you have to invoke inertial forces, which are not predicted in your system of mechanics, specifically centrifugal
Correct.
forces. You need Euler forces, centrifugal forces, and Coriolis
You're
forces.
talking about our model, not your. You're not telling us.
all
how
of
yours
orbital
works.
mechanics is
You guys
wrong
are
now?
all freaking out. You're freaking out, buddy.
So all
Okay,
of
so
orbital
No, we're just
mechanics
saying.
is
You
wrong
said
now.
you
hey,
Got it.
buddy, can you calm down?
said you
Can you
could
calm
show
down?
it.
No,
Hey,
I didn't
can you
ask.
calm down?
Hey, Witsit, I'm not
Can
asking
you
for
calm down?
orbital
I'm asking
mechanics.
about my
You guys
model. I
need
don't
to
Liz,
have
know.
I'm
some
not asking
type
about
of
orbital mechanics
decorum.
on the
It's not
It was
globe.
going to be
literally
I'm
me
not
leading.
talking.
asking for.
Oh my
Everyone
god.
stop talking
Orbits
really
don't have
quick.
Coriolis
You need to have
forces.
some type of decorum. It's not going to be two people asking questions and repeatedly interrupting someone.
Yeah, just
All
wait
right,
till
so
he's
Austin was
wait
in the
till
middle
he's
of
finished.
speaking.
Yeah, don't grab the talking stick out of someone's hand. You know, don't grab it out of their hand. Wait till they're done, and then you got the talking stick, and you can make your point. Otherwise, it's audio chaos.
So I only brought up your model because it leads into my answer, right? So, like in your paradigm, it's even acknowledged that I'm preemptively addressing any grasp at straws rebuttal here, right? So, like you still have to account for inertial forces. You claim that they're pseudo or fictitious forces. Those inertial forces are Coriolis, Euler, and centrifugal forces. So we just would claim that they're real forces. So if you have a stationary Earth, there would be a dynamic equivalence unless you want to dispute your own belief. And so you would have real inertial forces with the angular momentum of the universe. And you would have twice the magnitude of a radially inward centripetal force known as Coriolis force. It would be real force as opposed to some optical fictitious thing that you believe in. And then you would have centrifugal force, which we know is real. And my 3-year-old can demonstrate it with a string, a ball, and a stick. You know what I mean? So as you were to, if the universe was rotating, it would generate those real forces, and something could literally just be placed inside of that, and it would move all around us.
Excellent.
Yeah,
Witsit,
you're talking about lens
didn't answer the
theory.
question.
Lens theory, it's which is relativity.
No, lens
Well,
theory
you
is the
can't away from
relativistic application
Yeah,
of
the non-relativistic.
Oh my God.
Well,
Lens
dancing
theory.
away from the question, Witsit. I want orbital mechanics on the flat Earth, please.
Okay,
The
stop
math,
interrupting
not
me.
words, not the math, not the words. I want the math. Orbital
Okay,
mechanics
just
is the math.
stop
And
interrupting
globe,
me.
not globe. We want flatter.
Stop interrupting
globe
me.
geocentric. We're like setting up the criteria.
Yeah,
so then you can
actually,
answer it
this is
properly.
really messed up what you guys are doing. So, Pinky, you asked Austin a specific thing. He goes to answer it, and then NASA Shill asks Austin to do a thing, and then he goes to answer that, and then you tack on another point. Like, can we just have it like a regular
answering the question.
conversation without, like,
Dancing
Austin was in
away
the
from
middle
the
of
question.
speaking.
Can
Just
somebody
be-
shut them the fuck up?
Question.
No, we
Watch
don't
him,
need to do
watch
that
him
either.
dance away
I'm
from the
just
question.
saying,
Go, Witsit,
in any
answer the
type
damn
of
question.
regular conversation,
Come on,
why
stop
would
white
we
knighting
do
for him.
this?
Just give him the down. Let him.
He's not
Just
white
talk to
knighting.
them.
What we're
Okay.
gonna do is
Can I
it's
stand in
not
line for the
white
talking stick
knighting.
at some point?
Yeah, I'm just gonna let Austin make his
Thank
point
you.
before he got interrupted by like.
The funniest thing is I've been willing to answer all the questions. You guys just aren't even letting me. But so lens theoring is a relativistic application of the Machian principle. It isn't like the Machian principle is not exclusive to relativity. Neither of these dynamic equivalents are exclusive to a globe Earth because that's just a projection. So you could clearly transfer it over to the projection over a plane. And we've all seen the depiction of the trajectory of the ISS and the orbits of the planets over a plane, which actually ironically carries sacred geometry, and conveniently they don't go over the north or south poles. What a joke. So that's just a projection issue. The math would also be easily translated via that projection. The actual the dynamics themselves are built within your own orbital mechanics claim. So if you dispute that a stationary Earth could have these going around it with a rotating universe, then you dispute your own claim of orbital mechanics. The only distinction is that they're real forces on a stationary Earth, and they're just fictitious forces that are outside your system of mechanics in your paradigm.
Excellent. You didn't answer the question again. I want the math, Witsit, not the words. Second of all, there are satellites that go over the North and South Pole. The ISS is not one of them. The ISS is inclined at 51 degrees, I believe, because of the Russian launches. So once again, you haven't answered the question.
So you just totally deflected away from the ISS to invoke another claim of a polar satellite, which also doesn't go directly over the North. Which also doesn't go over the North or South Pole either. It just supposedly goes closer to it.
Pretty much right over it.
Oh, pretty much over it. So yeah, like I said, none of the satellites go over the poles. The ISS definitely doesn't.
Yeah. Oh, here again, the ISS doesn't. You're right. The ISS is inclined at 51 degrees. So what does that got to do with the math? So let's deflect away for again because you don't have the math to explain how the satellite works on the flat Earth. You just come up with some sort of blah 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 blah.
We can use the same equation that
No,
you
you can't.
use. Yeah, well, you don't understand it. Don't worry, I got you. So when you use a ECI or a ECEF, you're using, in terms of dynamics, you're using a stationary Earth, stationary globe Earth. Yes, that's irrelevant though. So you can see. So time out. So you concede that in terms of physics, the dynamics of the orbital mechanics, that you can show the math and physics of the satellites moving around on a stationary globe, and they work.
It depends on where you're orbiting, but okay. In the meantime, though, show me on the math on the flat Earth. I still haven't seen it.
Well, okay, but before we get to that step, you concede that
you'll never see it, NASA.
You concede that we've already done it, buddy. We've already done it.
Where?
That was like
Show it
4
to me.
years ago. Catch
Show
up.
it to me.
Go to Schooling
Show it
Globers
to
like
me.
12 episodes ago. I'll show
Yeah,
it
I
to you in
did.
just a
You
second.
didn't do it then either. You didn't show me the
Yeah,
math.
we've
You just came up with some
already.
sort of blah 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 projection, blah blah blah, explain it, blah blah blah.
Do you
Use the
want
same
an
math.
answer to your question?
No, he's
I do
desperately
want
looking
an
for
answer.
something I
He's
can't answer.
not answering the question though.
What I heard the answer was the word mock. He discarded lens theory, which is an actually well-developed theory that shows how it would work. Witsit said mock, and then he jumped from dynamics to kinematics to try to do coordinate transforms, which don't actually work because spheres and flat planes are not compatible.
Okay. So first of all, these are two different points. There is a dynamic and a kinematic point. I'm not jumping to anything. You're asking for both of them. Do you not understand that? So I'm not jumping from anything. Secondly, I didn't just say Mach. What I said was lens theory is specifically a relativistic application of Machian principle, which also exists in the Newtonian dynamics framework. So the Machian principle is independent of the specific framework of dynamics that you invoke, whether it's relativistic or Newtonian. What I want first is for you to concede that on a stationary Earth with a rotating universe, the satellites would be the same, the satellite equations would be the same, and it can be explained dynamically moving around a stationary Earth.
Kinematically,
What's
yes.
that got to do with the flat Earth?
No, dynamically.
What's that got to do with the
Well,
flat Earth?
using something like lens theory, yes. I don't know anything outside of that, like where there's actually, I don't know anything outside of that. Like invoking just Mach's principle doesn't like that. That doesn't seem like a satisfactory.
Okay, so if you want a Newtonian one, you can look at Luca Popov, the Newtonian Machian analysis of planetary motion. Okay, so he breaks it down, and then you can look at Andre Assis relational mechanics. He breaks down the dynamics of both the relativistic and Newtonian application. The point is that inertial forces are in your own equations, and they're claimed to be fictitious forces. Now, in your model, those don't actually exist. There is no centrifugal force in your model, yet conveniently enough to actually explain it dynamically, we have to incorporate a centrifugal force. So can you explain to me, well, whatever, you guys are going to be like, oh, we're not talking about my model, whatever. Your model can't even explain it without invoking a geocentric dynamical framework. Yeah, but my point is you don't have a model and it's retarded and it can't even explain satellites. So,
I mean, we can explain lunar eclipses. So that's
cool story. So we've established that there's a dynamic equivalence. In order to even make your initial satellite claim, you have to concede that satellites can rotate around a stationary Earth using the same inertial forces, only they're not fictitious, they're real. So then you guys are disputing that I can take
go around the Earth too, like everything in the solar. I'm legitimately asking you.
Well, there's different ideas as to what makes the sun move, but yeah, of